We are live.
Can we start now,
Shrutika ma'am,
ma'am?
we are live. We can start
Should
now.
we wait for? Yeah. Um, Good morning, everyone, and a very warm welcome to all our participants joining us from across the country. How many participants are there? Is it? Take care. We are delighted to welcome our distinguished dignitaries joining us virtually today. Honorable Professor Architect Abhay Purohit Sir, President Council of Architecture, Honorable Shri Gurmeet Singh Arora Sir, National President Indian Plumbing Association, our convener Dr. RASHMI.B.TANDON Ma'am, Deputy Director COA-TRC Delhi, and all our esteemed speakers, invitees, and who are watching live on YouTube. On behalf of Council of Architecture, I am Shrutika Joshi, Assistant Director of Council of Architecture TRC Delhi. It is my privilege and honor to extend a most heartfelt virtual welcome to each one of you at this National Capacity Building Program on integrated waters and sanitation, the blueprint of for sustainable architecture, jointly organized by Council of Architecture and the Indian Plumbing Association. A quick note for all the participants. This program is being live streamed on YouTube and is completed. Coordinators will convey them to our speakers. The feedback will be active for only for 15 minutes after completing all four sessions. Once the program is completed, coordinators will convey them to our speakers. The feedback link will be active for only for 15 minutes after completing all four sessions, and the certificate will be issued upon successfully submission of the feedback form. So this program marks a
Shruti,
significant milestone. Yes,
Shruti, wait, beta. You were not audible. Just tell the code of conduct again. I think there was some technical issue. Just show the slide also that code of conduct. It's not shown on the screen. And speak again.
am I audible now? Ayushi, are you there?
Yes, you're audible.
Yes, ma'am, you are audible.
Yes, yes, okay.
Yes, you're audible. Let's begin again. Sorry for this. I mean, there is some technical problem. Shruti's computer was not on network, I guess, but now it is all resolved. Let's begin again. Please show the second slide.
So, a quick note for, sorry, I will start from the starting. Good morning, everyone, and a very warm welcome to all our participants joining us from across the country. We are delighted to welcome our distinguished dignitaries joining us virtually today. Uh, Honorable Professor Abhay Purohit Sir, President Council of Architecture, Honorable Shri Gurmeet Singh Arora Sir, National President Indian Plumbing Association, our convener Dr. RASHMI.B.TANDON Ma'am, Deputy Director Council of Architecture TRC Delhi, and all our esteemed speakers, invitees, and watching live on YouTube. On behalf of the Council of Architecture, I am Shrutika Joshi, Assistant Director, Council of Architecture TRC Delhi. It is my privilege and honor to extend a most heartfelt virtual welcome to each one of you at this National Capacity Building Program on integrated water and sanitation, the blueprint for sustainable architecture, jointly organized by Council of Architecture and the Indian Plumbing Association. A quick note for all the participants: this program is being live streamed on YouTube YouTube participant must share their name, designation, and affiliated college or office name in the chat for attendance. uh, for post questions in the chat with your name and your affiliated college or office. For the Q&A session, coordinators will convey them to our speakers. The feedback link will be active for only 15 minutes after completing all 4 sessions, and certificates will be issued upon successfully submission of the feedback form. So this program marks a significant milestone. Both organizations have come together to bridge the gap between architecture and plumbing, and we are honored to have them share their insights with us. To present the vision and framework behind this program, I now most respectfully invite Professor Architect Abhay Purohit sir, President of Council of Architecture, to kindly address our audience on YouTube. Sir,
I think Shruti, let's move to Gurmeet sir. Sir will take some time to join. He's in a meeting.
to share the idea and passion behind this program. From the Indian Plumbing Association's perspective, I now most respectfully invite Sri Gurmeet Singh Arora sir, National President, Indian Plumbing Association, to kindly address our audience. Sir, we warmly welcome for you to speak.
Thank you, Shruti ma'am. Good morning to all of you and all the distinguished speakers, respected members of the Council of Architecture, colleagues from the Indian Plumbing Association, and many young and practicing architects who have joined us today. It is a pleasure to address this one-day online capacity building program on integrated water and sanitation, the blueprint for sustainable architecture. I would like to tell you something about IPA. We are a 33-year-old body with 13,000 plus members, and we are all over the country. Our scope is to enhance water supply, look at how we can reclaim used water, and of course, make sure that we have current and proper plumbing practices as per the codes. I would like to extend sincere thanks to architect Abhay Purohit ji, Mr. Raj Oberoi, Mrs. Rashmi from the Council of Architecture for their leadership and support in strengthening collaboration between the architectural community and the Indian Plumbing Association. Such partnerships are essential for advancing sustainable practices in the built environment. Today, water has emerged as one of the most critical resources shaping the future of our cities. Rapid urbanization, population growth, and changing climate patterns are placing unprecedented pressure on urban water systems. As professionals engaged in shaping the built environment, we share a collective responsibility to ensure that water is managed not only efficiently but also sustainably and responsibly. For architects, water is no longer just a utility component within buildings, it is becoming a central design consideration. Issues such as water scarcity, inefficient plumbing layouts, inadequate sanitation planning, and poor wastewater management are increasingly affecting the performance and resilience of our built environment. In many projects, architects face challenges such as limited awareness of plumbing integration, lack of coordination between design and engineering teams, and insufficient emphasis on sanitation and water reuse systems at the planning stage. These gaps often lead to inefficient water use, operational challenges, and missed opportunities for sustainability. This is where the concept of integrated water and sanitation planning becomes extremely very important. Traditionally, water supply, drainage, wastewater management, and sanitation systems were treated as isolated elements within building design. However, sustainable architecture today demands a far more holistic and integrated approach, one where these systems are planned together from the earlier stages of design. When architects and plumbing professionals collaborate closely, we can create buildings that significantly reduce water consumption, promote reuse and recycling, improve sanitation standards, and protect natural water resources. And of course, plumbing infrastructure. In other words, our buildings must evolve into water efficient ecosystems within our cities. It is with this vision that the IPA and the COA have come together to launch an exciting initiative, the Indian Architectural Plumbing League, or IAPL. IAPL is envisioned as a knowledge driven platform for the architectural community, especially for young and emerging architects. Its objective is to strengthen the understanding of plumbing systems, water efficiency, and sanitation planning within the architectural practice. Through structured learning modules, expert mentorship, technical knowledge sharing, and practical insights, IAPL will provide architects better integrate plumbing systems into building design and improve coordination with plumbing professionals and engineers. Equally important, it will help sensitize the architectural community towards water stewardship, enabling architects to play a proactive role in designing buildings that are water efficient, water sensitive, and ultimately water positive. Today's program also serves as an orientation towards IAPL, giving participants a glimpse of how this initiative will help build stronger technical capacity within the architectural profession. I would strongly encourage all the young and practicing architects present here to actively participate in this initiative when it is formally launched in April. Platforms like IAPL will not only enhance professional knowledge but will empower architects to contribute meaningfully to water conservation, improve sanitation, and sustainable urban design. I'm sorry, I'm sitting in a hotel room and they're drilling outside. I'm sorry, because the future of our cities will depend not just on how we design buildings, but how we responsibly design water systems within them. Before I conclude, I once again thank architect Abhay Purohitji and the Council of Architecture for partnering with the IPA in this important initiative. I also appreciate all the speakers and participants for being part of this knowledge sharing session. Together, let us work towards designing buildings and cities that are not only functional but beautiful and also water efficient and sustainable for the future. Thank you, and I wish the program a grand success. Thank you very much.
Thank you so much, sir, for those warm and energizing thoughts. The energy between architecture and plumbing has never felt more purposefully than it does today. Before we begin our sessions, I now invite Dr. RASHMI.B.TANDON, ma'am, Deputy Director, COA-TRC, to formally walk us through the structure and objective of today's program. Over to you, ma'am.
Yeah, thank you, Shruti. A very good morning and a warm welcome to all our participants joining from all parts of the country. And it is our privilege to have you all here today for this National Capacity Building Program, which is Integrated Water and Sanitation, the Blueprint for Sustainable Architecture. This one day online program is a joint initiative by the Council of Architecture and the Indian Plumbing Association, as Gurmeet sir has already briefed. And we are deeply grateful to both organizations for their vision in bringing this critical subject to the forefront of architectural discourse. To everyone who has registered, the practicing architects shaping our built environment, and the academicians molding the next generation of professionals, a very hearty thank you to all of you. Your presence here today signifies a collective commitment to building a better, more responsible India. Let me bring everyone's attention to the need of the hour, why this discussion is critical. We often speak of sustainable architecture in terms of energy, materials, and green covers. But today, we turn our focus to the very lifelines of our buildings and cities, which are water and sanitation. Why this is so important, and especially now? We are living in an era of unprecedented challenges. Last 6 years, we have gone through a big change in our life. Our cities are facing acute water scarcity on one hand and the threat of urban flooding on the other. Groundwater tables are depleting at an alarming rate, and our water bodies are polluted. The recent past has taught us, in no uncertain terms, that sanitation is not just about convenience, it is about public health, dignity, and resilience. For too long, water and sanitation have been afterthoughts in the design process, handled as mere service requirements to be fitted in the architecture when architecture is finalized. This approach is no longer tenable. Today, we need a paradigm shift. We need to move from seeing plumbing as a utility to recognizing it as an integral part of the architectural blueprint. This is where the concept of integrated approach comes in. It's about designing systems where water efficiency is baked into the design from day one, not added on later. Rainwater harvesting is not an afterthought, but a fundamental site strategy. Wastewater is viewed not as waste, but as a resource that can be treated and reused. And where sanitation planning is seamlessly woven into the fabric of our building to ensure health and hygiene for our occupants, and just to provide a proper well being to all. Now, about today's program, this capacity building program is to strengthen our knowledge base to highlight the immense importance of efficient plumbing systems, forward thinking sustainable water management practices, and integrated sanitation planning. Over the course of the day, our expert speakers from the Indian Plumbing Association will bridge the gap between architectural design and engineering precision. They will provide you with the practical insights and tools needed to create buildings that are not only aesthetically pleasing, but also environmentally responsible and resource efficient. Whether you are a seasoned professional looking to update your practice or an academician eager to bring these principles into your curriculum, this session is designed to empower you. So let's embark on this learning journey together. Let's reimagine how we design by placing water and sanitation at the very heart of sustainable architecture. Once again, a very warm welcome to all. We hope you all have an insightful and enriching day ahead. And also, to one and all, we will just keep telling you about this. Gurmeet sir has already announced that this is like a precursor to a 5-day program, which is like an offline program being planned again in collaboration with IPA. And this 5-day program, which will be hosted in Delhi, and we are calling it Indian Architectural Plumbing League. It will be formally inaugurated, and the first of its 5 sessions will be between 6th April to 10th April. So keep following us and we will keep sharing the details with all of you. And thank you so much. And let's not wait much. And over to you, Shrutika, to start the program. And if Abhay sir is here, I think let me just check if he's here. So we can also ask him. Uh, okay, maybe whenever he joins in between, then we can ask him to intervene. Yeah. So
Sure,
let's
ma'am.
begin with the deliberations for the day.
Ayushi sir is joined, you said. Ayushi, you are there?
I don't see sir here. You may
Okay, okay.
begin.
Let's start with the session. Uh,
I think sir is waiting. Maybe he's joining in a minute.
okay, okay. Let's wait for a minute then.
So, meantime, you can introduce Prasanna sir. I think his introductory slide can be shared and he can be introduced.
Sure, sir. Sure, ma'am. Thank you, Rashmi ma'am, for the comprehensive and clear overview of the day ahead. Dear participants, we now start with the session. Just for a building is admired for its beauty, but was what sustains it and the lives within it runs silently behind its walls. Plumbing is not merely a technical afterthought; it is the very backbone of public health and building functionality. Our first session, the foundation and the fixtures, will take us through the why and the what of plumbing as a design discipline, exploring modern water efficient fixtures, innovations, and revealing how an architect's early stage decisions directly shape a building's water footprint, use comfort, and long time value. I now introduce our first speaker, Sri V.O. Prasad Kumar sir, a distinguished engineer whose expertise in plumbing design and building services brings both technical rigor and practical clarity. We are privileged to have him with us today for this meeting. So,
Yeah, I
can
think
we?
Purohit sir had some problems joining in. So the link has been shared again with him. So till now he has not joined, but whenever he'll join, we'll ask him to welcome everyone. But we can begin with Prasanna sir and his presentation.
Okay. Prasanna, sir, over to you, sir, for the presentation. Let's begin with
Yeah,
the session one.
yeah, you can connect.
And to all the participants, please, sir, sorry, I'll just take 1 minute. To all the participants, the sessions are now beginning, and I request all of you to be attentive and keep sharing your queries and questions for Prasanna sir on the YouTube live chat. And our team will collect all your queries and pass on to us, and we will take up after the session is over. Likewise, we'll do for all the session. Thank you so much. And sir, over to you now, sir.
Yeah, you need to stop sharing now. And good
Yes,
morning,
yes,
all,
yes, please.
and welcome to the session one of the one-day online capacity building program, which is combined organized by COA-TRC and Indian Plumbing Association. Can you stop sharing? Am I audible?
You are audible.
Yeah. Yeah. Click it. First. Is the screen visible now?
Yeah, visible.
Visible?
Yes, it is.
Thank you. Thank you very much. Yeah. Once again, good morning, everyone. Is the first day, first session, the day one online capacity building program. The caption of the capacity building program, it was very carefully chosen. That is integrated water and sanitation blueprint for sustainable architecture. And my session is on the foundation and fixtures. So to begin with, all our presentation now, the plumbing is revolving around water. Particularly, you go back to the major civilization and river valley civilization. See, water is both united and divided among the human being. Without water, there would not be any civilization. It is so proven. We have no other planet which is so far proven. There is the availability of any water, oxygen, or something. So the plan A is the Earth. Plan B, we don't have anything. The nearest planet which is studied was the Mars, and absolutely the still the plan B is the plan A to save Earth. So hence we need to look after the water and civilization very carefully. The prehistoric also learned to collect the rainwater harvesting system, which was depicted in the picture, and I think second slide is visible. So the storage purpose, we used to have the duct basins known as cisterns, and in the form of earth and rock, and also mud is used for the fabrication, filtering the water before consuming that water. Once again, irrigation was predominant, the water being extensively used, and channels were being created so that there is a strong movement of water within the channel so that water is not getting stagnated or seeped into the dry ground. Hello? Hello? Yeah.
Yeah, you're
So,
audible.
Yes,
yeah.
sir.
So water and civilization is moved to further see, water is also acting as the boon and for the livelihood, and also water is acting as the cooling purpose, washing purpose, for avoiding the wild animals, and this one, it is also creating a barrier around that the built environment. So prehistoric time, they also know how to build the embankment along the river so that villages are surrounded, to avoid any undue flooding across the areas. Now coming to little technicality, when you look at the prehistoric time, it is what we call today is the order of hydraulics, which they were knowing very well on the order of hydraulics. It is the equilibrium between the land and water which we obtained, and it is creating a systematic barrier. It's of the water is flowing in the valleys, and we have they have created the headwater drainage management. The offline storage system is being done. Catchment and woodlands are being provided. The pockets of park and all that wet area is being created and channelize the complete amount of water. This is what the order of hydraulics. Water is finding its own way and to its places. So coming to the as you all architects know very well on the different civilization, where Greek and Roman civilization, the ancient numerous cities would have at that time would have the water fountains to supply water for everyone, and aqueducts were created to supply the water from a lower range to different areas where water was not available. The art of sending the water through the aqueducts were known. The ancient pumping was the biggest water wheel, which was nowadays we call as modern pedal wheel, but it also generating electricity and also transporting the water. Now we call that as a hydroelectric power. So at the same time, the civilization was also knowing differentiated use and collection of water. So fresh water being transported to the areas wherever the requirement of the human consumption. At the same time, they want to keep the water away from the human habitation through the underground system, which is very well depicted in South Asia, South Asia, particularly India, Pakistan region. It was a very predominant at that point of time about water supply and drainage system. The hydrology is also
Can
used
I
for the.
intervene, Prasada?
Please, yes.
Abhay Purohit ji has joined President of Council of Architecture.
Yeah.
With your permission, can he give his speech in between?
Please,
and
sir.
then you
Please,
can
sir.
carry on?
We would love to hear from him. I'm just stopping for a while.
Yes, please, sir. Thank you. Thank you so much.
Stop sharing. Yeah, I stopped, sir.
Abhay ji? Purohit sir?
Sir.
Sir, can you give your opening remarks, because then we can carry on with the presentation, sir.
We are honored to have Professor Abhay Purohit sir to present the vision and framework behind this program. I
Put
now
on your
want
cameras,
to...
we can take a photograph together also.
Am I audible?
Yes, sir.
Yes, sir. Oh.
Yes, sir. Good morning, sir.
Rashmi, I think we can continue. The presentation was going on, right?
Sir, we have just paused it for a while. You can give your opening remarks. And even Gurmeet needs to go.
No, it's good actually, because I was listening to it. Only thing is that the connection was becoming a sort of the issue. So yes, I'm very very happy to be part of this. Gurmeet ji is also there, and this initiative between Indian Plumbing Association and Council of Architecture. I'm very sure that it is going to take us to a different level, because we are looking at as a Council of Architecture, sustainability is one of the very very key areas of a focus. And we also believe that architects, they need to be acclimatized to basically the higher levels of how are we capable of achieving the sustainability through basically the systems which are present in the buildings. And I'm very, very sure that Indian Plumbing Association is going to be a good partner, whereupon we would be capable of also sensitizing the architects, the students also, and with that as such we would be capable of bringing a very, very positive change into the entire built environment. So with that, I'm very, very sorry that because of the technical glitches as such I was not there, though I was listening to everybody. So I think without much of the waiting, let us start with the presentation, because putting up the presentation in between as such is not really a good thing to happen. So let us be there. Welcome all participants. It is a good initiative, and I'm very, very sure that with this kind of a maiden effort, now we are going to be actually capable of doing something which is much, much, much more meaningful. So best of luck to all, and thank you very much for accommodating me right in the middle of the session. Sorry for the technical glitches which had happened. Thank you very much.
Thank you so much, sir, for those truly
Thank you
inspiring
so much,
words.
sir, for those truly
Your
inspiring
vision
words.
for this collaboration sets such powerful tone for everything we will explore today. Prasanna, sir, we should continue with the presentation. Prasanna, sir.
Prasanna ji, you are muted.
Is this
Yeah,
screen visible now? Screen
yeah,
visible?
perfect.
Yeah. Thank you very much, Abhay Purohit, for your kind words. The association will continue between COA and IPA seamlessly, and we also in IPA would like to continue with the sustainability program in a big way and joining hands with you and your team. Thank you very much for your kind words, sir. Just to continue with the hydrology and flood mitigation, Minesh, my screen is visible. Yeah.
Yes, it is visible, sir.
Yeah. Okay. So there are instances you take only 1,000 years back, the Cambodia, that is the Khmer ruling, they built the complete Angkor, the township with around the water. And water, they used it to different purposes, both navigation, the protection, the consumption, and disposal of the treated water, which is very evident on the things. For architects, the best example worked around the water was Brenta and Marmor towns, that is in northeastern Italy. The Villa Contorini is developed in 15th and 18th century around the water. Basically, this water is used to navigate the control flooding system, everything around the water, which is done very well. So history is giving us the lot of thoughts to continue to manage the water. As Rashmi-ji earlier, she said, we need to respect water, and also the water and flood water is a resource rather than a curse for the cities. So now you take an example, the current examples of tanks in Karnataka. Uh, the Karnataka tanks in the earlier days, kingly time, which was designed as a cascading tanks all over the city. Now there were 1,000 tanks. Now it is all reduced to around 200 tanks. That is the pathetic story of the things. And the step wells of Rajasthan and Gujarat is another example where the cylindrical wells store the water for the summer season and increase the water table. Tankas in Rajasthan, once again, the receiving the groundwater, the rainwater storing as a groundwater system. Bamboo dripping arrangement, sending the water to longer distances in the northeastern, very hilly area, and diverting that water for the use. And another important, this one in Bihar, that is Paine Ahar, that is the cascading kind of the lakes and system which are used to send the waters from one land to another land piece and that is where water is being efficiently used. Now, water is always been the heart of human settlement. And coming back to that, for all that input, for today's program is on the plumbing, water, and sanitation. The foundation program, which is my the first session of the topic, just to understand what is plumbing. The plumbing for all of us is the system of pipes, fittings, appurtenances, the heater, the geyser, the heat pumps, anything related to water which is flowing through the water, whether the incoming water or the used water which is going outside or the storm water, collectively we call as the system of plumbing. Once again, the plumbing system fundamental is the source of water from lakes, reservoir, or municipal supply, where the water comes to our project, storing that water and distributing that water within the network, use through the plumbing fixtures and system, either by the gravity or the pumping system, depending upon the how far the water being sent, either by gravity or through the hydromatic system, and collecting the disposal of the sanitary waste or stormwater and going back into the source again. So this is the fundamental of water infrastructure. Now we need to see closely the water infrastructure and human-centric design, particularly to connect with the architect and the plumbing designer, and in fact all the engineering things. Since architect is taking the lead role on the project, so the modern architecture is relies seamlessly on integration, particularly the multiple building system. That plumbing infrastructure is closely working with structural engineering, mechanical, environmental designs, and architects and planners must treat water infrastructure as a strategic design rather than the afterthought. It was explained thoroughly by Dr. Rashmi in the opening remarks. And architects also incorporate these strategic in the earlier planning stage, so that the significant the space allocation or the inclusion of the plumbing system can be seen much in advance. Also, the focus of the design is for the healthier living and environment, so that there will not be any crisscross of the fresh water to the polluted water, and the user comfort and the safety is achieved through proper planning and integration of the things. So for a plumbing service design is always starts with a focus of, one is adhering to all NOCs. That is, no objection certificate given for the project through MOEF or the water authority or the pollution authority or many authority. We need to include in our the plumbing the design services. Then the codal requirement is also paramount important. Land of the law, we need to abide by that, and the technical updates, because year on year we are seeing the newer material which are coming into market and which is finding new usefulness, either explaining the sustainability properly or reducing the water consumption. There are many things which are happening around, and innovation, we need to look into that. And all said and done, every time for the clash between architect, the engineers, and the client is space optimization program. Why are we taking so much of shaft space? Or why is this the project is having so much of an water tank capacity, STP tank capacity? It is actually optimizing the thing for the human comfort. It is not that engineers wanting or architects is not giving or client is denying. It is a optimization of things we need to firm it up thoroughly. And environmental concern and the sustainability is the thing. And all said and done, ease of constructability we need to address. So for that, the use of codes and standard, actually standards are making the benchmark for the minimum quality. For achieving the maximum quality, the sky is the limit and the economics of the project is the limit. The conformity and competitiveness we need to bring in. Global acceptable standard we need to use, because if you want to import some material, there should be a proper standard. For example, the outlet of EWC is 4 inch. It is worldwide, it is 4 inch. So that the global acceptability of the standard and use of different material across the world become user. So the codes and standards are helping in a big way. So now codes and standards for an engineer, I'll define one by one on Act, Regulation, Code of Practice and Guidance. For better practice, we are using the following codes which are mentioned. Petroleum Act, basically, which is being used for storage of diesel for our generator. Regulate the RERA Act, which we used by the architect. The Environmental Protection Acts, which is dealing with air, water, and sewage. The Environmental Conservation Sustainability Building Code, which is recently revised as ECBC, which IPA is also part of code development for water and other things. This is the code of practice which is in existence. The Electricity Act, which defines the do's and don'ts on electricity, use of electricity, supply of electricity, everything. So basically, these are the practicing definitions. The Act, basically, Act is the primary law, which is passed by the Parliament. So that become a framework. It is a legal framework under which regulations are being formed to comply the Act. That is what the technical rules by the individual governments, which are doing, state governments, which are enforcing the thing. And code is the standard practice and are the best practice which is available to us to follow the laws, regulation and standard. Particularly for us, all of us, is the National Building Code of India. Even though we call this as a prescriptive code, the prescriptive code become mandatory when it is passed through NOCs. For example, MOEF says in one line, you need to follow the National Building Code of India. Even though it is prescriptive, it become a mandatory thing. So these are the guidance and standard practices. Finally, we end up in using the guidance material, which our manufacturer instructions, all that available through the catalog, which we are using seamlessly for the better installation process. There are mainly three things in plumbing system. As I told you earlier, the potable water, bringing the clean water, the sanitary drainage and ventilation system. Sanitary is the soil waste pipe and venting system. Stormwater is the rainwater handling and rainwater and drainage handling. Wherever the snow melt in the upper reaches of India, the snow is also considered for the stormwater drainage when it is melting. So these are the things which in the plumbing system are being dealt with. You come to one by one of the activity, particularly on the parameters for the design of water supply is either the density of the project or the height of the building, which also determine the type of building, the flow demand, how much water is required is being calculated, and accordingly the space requirement will be asked to the architect to provide so much of space for storing the water, treating the water, treated water being stored, the pumping the water and pump station requirement. That all forms the undergone some detailing requirement which are being provided. The water, the pipe and the valve requirement is the part of the water supply design. The riser location, particularly the shaft which are required in a high-rise building or any building per se, need to be provided to take the pipes, whether it is a water rising main, down takes. All these details are covered in the next session. Particularly these design aspect which I am highlighting is basically on the space requirement for the plumbing system is given by the architect to any plumbing engineer. So acoustic economics is also a requirement. For example, the water distribution system by gravity, I have just shown an example of a 5-story building, which is having the top floors as hotel, bottom floors as office, retail, everything. So the system is being designed to give the water to every toilet and wet areas wherever it is being required. Here in a gravity system, the system which is one of the system which is designed to send the water from underground tank to intermediate tank. There are four intermediate tanks, water is being pumped. Why intermediate tanks? I am not pumping the water where water is required at second floor, where I am pumping all that water to the 105th floor and taking that water and reducing the pressure. It is a wastage of energy. It is not a sustainable thing. So I am stratifying the building into intermediate water zones, keeping the sump at a different level, and those areas are well treated for example, for fire refuge or keeping HVAC requirement or any other intermediate requirements. So that now here in this plan, I am pumping the water from ground floor to say about 25th floor and taking the water down. And from 25th, I am pumping the water to 50th floor, 50th to 75th, 75th to 100 floors, and water is only traveling wherever it is required at between the 25 floors. So these are the stratifications which we need to do. That was as far as the gravity was concerned. Where shaft requirements are narrow and availability is not there, there is no storage spaces are provided intermediate. There is another system called hydropneumatic system, which is pumping water from the basement wherever the underground some pump room is situated up to the required areas. The water is being pumped once again in a stratified manner between lower floor by the low level pumps, higher floor by high level pump, and mid level pumps, so that it is once again addressing sustainability and less use of energy. So just to understand the total water cycle conventionally, what we used to do earlier, the collection of rainwater, taking from lake or dams and treating that water and sending that water to the project and taking that water back into the system and treating to some quality and letting the water into the water bodies again or stormwater drain again. It was a very conventional system, which is now it is not applicable as far as sustainability we want to address. Now we need to move to intelligent water supply system, where intelligent water supply system is made up of technology. The direct rainwater harvesting scheme is being used, recycled technology is being used, treated water is being used for air conditioning purpose, irrigation, street wash, many other systems. And also technology is being used to check the water leakages and reduction to control the water movement within the system. And desalination water wherever the source of water, fresh water is not available and accessibility to sea is there. All that coastal area desalination method is being used to treat that water by the RO standard and circulating back. So this become the complete resource is being used, reused, and retreated and used in the entire cycle. Similarly, on the sanitary and drainage system, the first golden rule is to send that water, used water, using the nearest, shortest route as far as possible to the sanitary drainage system. In our project, sanitary drainage system may be external sewer line system, which is letting the sewage into the municipal sewer, or the sanitary system may be combination of our sewage treatment plant, letting our water into the sewage treatment plant, treating and using. That is where the shorter distance, the shorter the movement of water, lesser the problem due to the plumbing. So this is the golden rule. And we need to provide clean out plugs, traps, vent, all these for the maintenance purpose. It should be strategically located and accessible at places wherever the cleaning has to be addressed. The subset of the above rule is the waste collection system, which I already explained. Ventilation is generally overlooked into that because the ventilation or the foul air which is not going out of the complete sewerage system can create a disaster effect or health effect on the user within the toilets and all these areas. Some of the definition on drainage system is the wastewater. We need to understand while talking, we need to understand what is wastewater pipe and what is soil water pipe. Wastewater, as it is said, it is the liquid waste free from fecal matter. The wastewater does not contain any waste coming out of EWC, WC, and all these things. Whereas soil waste, which is only the waste coming from the fecal matter. So wastewater, whereas it comes from the bathroom, the wash basins, and all other areas. So vent pipes is a mandatory, as I already told you. The circulation of air within the plumbing system is mandatory to avoid negative pressures which are developed, or trap seals are being lost. Trap is another very important fitting to give the isolation of foul air entering in our the toilets and the kitchen areas. So traps maintain the water seal of required depth, that is 50 mm, and the water only goes through the trap seal, air will not travel back. And we always call as the vertical stacks. Stacks is basically the soil waste and vent pipe which are housed inside the plumbing shafts. Those are called stacks, and branch which are leading to those shafts are called the branch lines. Once again, on the house, the sanitary drainage system, which is having two parts. One is sanitary drainage from the soil and waste and other drain pipes within the building. That is basically the foul water, which is directly going into the external sewage lines, and the stormwater, which is directly going into the external stormwater drain. This is where we call our sanitary drainage system as two pipe system. Sanitary for the wastewater separate and stormwater separate. Now, to accommodate the sustainability aspect, taking it further, we have different fixtures fittings which are available. The flush valve and the cisterns. Generally, flush valves looks very smart, cute. From the outside, the with the use particularly the flush valve, which requires minimum of 1 kg pressure. The topmost floor where 10-meter head of water is not available, flush valve may not work efficiently. At the same time, the efficiency of the flush valve is very good where when you take a 3.5 kg pressure, but incidentally, that is the limiting pressure which we are using that in the pipeline system. And cistern is also we are using wherever possible, and the flushing cistern will accommodate a flushing cistern tank holding required amount of water, and it can be inbuilt or it can be exposed also. Particularly, the maintenance may be required in flush valve, and regular maintenance may not be required in this one, but still it is a debatable thing. It all depends upon the maintenance frequency of each system. When you all house all this, do all your drawings, give it to the contractor. This is where in which the good plumbing installation probably look like. It is a well-designed, well-accommodated, which is kept away from the areas where we cannot take the pipes, particularly lobby area or any other area where you cannot accommodate. We can take it on the driveway areas. It is housed properly by plumbing engineer. If you are not taking the service of a good plumbing engineer, what we ending up with? The bad plumbing installation program. You can look at this piping arrangement. Even though the connectivity is all good, there is hangers are missing, the proper detailing is missing, the pipes are hugged to the wall, there is leaking around the wall, and these are the bad plumbing installation and practice. So now we just move into the what is that resilient plumbing means. Resilient plumbing is the system in which it kicks back whenever the some natural disaster. For example, you have the cloudburst situation. Still, your rainwater pipe has to take all that water down to your sump or external drainage system. So it should be accommodate the all that natural disaster, the high demand situation wherever you have the water supply being designed, and whenever you have a event situation where water consumption is more, your plumbing system has to be very resilient for supply of those kind of water. So always the design also to be you need to ensure all that the system integration through the proper design. The ensure the distribution should be across multiple floor, particularly on very high-rise building, high-rise and very high-rise building. The pipe management, the design management takes a very important role, where the help of architect is required to accommodate required size of the shaft, and also the platforms in the shafts are required for the maintenance. So now few terminologies which I'll just run through that just to know as the to interact with the plumbing engineer, you need to know the terminologies and glossaries of the terms which are frequently used. Aerator is the fitting which is fitted at the end of the tap, which mixes air and water and also reduces the amount of water which is replaced by air, but still it gives the human comfort of hand washing the experience. So it is like it is this we call as a aerator fitting, and it is also a water saving fitting. So air brake is a system. It is a the whenever the plumbing pipe enter the plumbing system, the drainage system, and water is being drained to the traps, where we need to maintain the gap between the wastewater line, which you can see in the black color, and this one. The best example for this is the walking cooler, where it generates the liquid amount of water which you cannot directly connect back into the pipe, where the walking refrigerator holding foodstuffs, where pipe is directly connected to the external sewer line. The bacterial growth happens across the pipeline and spoiling your the walking refrigerator. So the water is being dropped into the flow trap through the air brake. So like that, the air gap is also maintained between the water distribution from the tap to the flood rim of the this one, so that the fresh water is not getting contaminated from the used water. And the same time in a drainage, which I explained earlier, the walk-in cooler or any refrigerator, the water has to be dropped into the system, not connected directly into the system. This is also called air gap. The back pressure valve, which is controlling the downstream pressure, which is having 3.5 bar, and upstream is 3 point and downstream is 1.5 bar, which is forcing the downstream pressure is exceeding the supply. Then it back pressure comes, and the flap which you see is being stopped due to that. So once again, the siphonage is the best example of siphonage is we might have seen in the municipal water connection, which is taking a connection from the municipal water supply line to our sump. Whenever water supply is stopped, if your water pipeline is submerged, the water is being sucked back into the municipal water line. This is called back siphonage. Sometimes if it is if the polluted water is being connected, the polluted water enters the fresh water line. So nowadays there are a lot of appurtenances, and the equipments are devised to do the backwater valve, particularly in a basement situation where we are leaving our water into the external drain, probably by gravity wherever it is possible. But whenever the outside water level increases, there are chances that water can come backflow into the basement. To avoid this, we are using at the end of the delivery line, we are fixing the backwater wall. It allows water to go from basement, but it is not allowing the water coming to the basement from external drains. So battery of fittings, generally it is the adjacent similar fixture which are fixed together, which may be requiring a vent, and this is generally in a plumbing terminology called battery of system. Drainage system, the terminology is the horizontal branch pipe, which are circled here and which are connected back to the building drain system, and back which is connected outside into the municipal system, that is called building sewer system. Building sewer system to the public sewer system. Wherever below grade of the street manhole, if we are developing the water, we need to lift that water, putting back into building drainage so that it will go by gravity. Otherwise, naturally, the building subdrain, all that water collected in the basement, which is coming only in the sump, then water has to be lifted. So these are the generally used terminologies in plumbing. And the bypass is another system, as the word literal meaning is bypass, which is a alternate arrangement created for any system is called bypass as a general English definition. In the plumbing also, if you are doing the bypass is to isolate one of the thing is not working in the system. For example, we have the two PRVs which I have tick mark as a correct. The PRV of one which is left hand side is not working, that is being shut off through the wall, and the bypass connection is given in the straight line. So this is called bypass line. Where this incorrect position is, we don't provide a pressure reducing wall on the other line. So it is not called as a bypass. The picture also showing the wrong installation of bypass system. The carrier fittings generally we call as the stands which are manufactured readily, where in the red one, which is directly EWC, can be mounted here. The green one, EWC and flush tank, is mounted on this one. The black stands which are taking care of wash basins or the urinals, which are generally called as carrier fittings. Cowl, as we know, it is the pipe hood which is fixed onto the top of the system, where all that foul air is exiting from the rooftops. CPVC, generally everybody knows as CPVC pipe as chlorinated polyvinyl chloride pipes, and which are extensively used for the water supply system. The development length, this is a little too technical terminology as development length. Why we are emphasis on this is, there is a wash basin which is connected, and the waste pipe is taken into the trap. Development length says it should not be more than 0.6 meter. That is the importance. If it is there, we need to have different trap system to reduce the development length, allow the water movement properly. So these are called development length. And diameters generally in India, for metric system, we call nominal diameter. For example, 4-inch diameter we call as a 4-inch, but 4-inch is a nominal diameter, and that we in a metric system we call as 80 mm diameter. In American standard, the nominal pipe size, they're calling the outer dia as nominal pipe size, and European generally call inner dia as nominal size. For all practical purpose, we say in metric unit is nominal dia is the central line dia of the pipe, which is defined very well in our National Building Code and IS codes. So generally we call a terminology dry and wet areas in a toilet. The upper picture shows the wet area is brought at the center. Generally, as a plumbing engineer, we are not recommending the top one. because the wet area is a shower area. There is a stagnation of some amount of water within the wet area. To use the WC on the left hand side of that, you need to cross the wet area. There is chances of slip and all. So these are not the recommended design stages. We need to push the wet area to the corner. Your frequent utilization may be wash basin and DWC. Whenever people are taking bath, they are entering the wet area with carefulness. But the accidental things can happen in the top figure, which is not recommended. The bottom one is a generally recommended thing. In another terminology, which we call as drain, waste, and vent pipe, which are all shown in this in the picture which is shown here. Water is coming from the wash basin, which is always carrying the wastewater and sending the water into the waste stack here. So this stack, the arrow mark which is shown here, which we call as wet vent, it acts as vent as well as the water which is entering here. Whereas the top vent we are calling as a dry vent, which is taking the pipe where there is no water movement is happening. Rather, all that foul air is entering into the vertical vent stack. So these are the common terminology which we use. The emergency eye wash stations, particularly in a factory environment or wherever hazardous material is being used, these type of systems are being used, which are properly pressure controlled, the flow controlled, which should not affect during the washing in an emergency situation. It also can be used for face wash. Wherever the people working in hazardous environment, they might require a quick face wash or eye wash in an emergency situation. Another emergency arrangement in a plumbing system is emergency shower, which is used once again in hazardous area wherever the chemical manufacturing plant or any hazardous thing where they quickly requiring a emergency shower to soak their body or clean up their body, which they come in contact with the chemical. These are installed in the emergency shower areas. Ferrule is a connection which we are making in directly into the municipal water line to take the service water connection to individual sumps or wherever our water is being taken from the municipal area without being cut the municipal water line. It is a making a saddle hole insert and fixing this. So there is minimum damage on the municipal water line. So ferrule is being used. The flood rim is the top hole which is made in the wash basin. You may not have frequently observed. Please observe this. This is provided for the purpose of not to overflow the water in case of chokage is happening within the trap within the wash basin. The flood rim will take care of all that the water which is not spilling outside the wash basin. Ball wall, generally it is a control wall. Whenever the water level increases, may it be in a toilet tank or underground sump or overhead tank, the water is being stopped automatically by lifting this float valve. That is called float ball. So grey water, which I have already explained, grey water is the water which is coming other than WC and bidet and urinals, but rather grey water is from bathtub, shower, bathrooms, which I already explained. Generally, the water from kitchen and dishwasher is not considered as grey water because it contains organic material which require little extensive treatment, which is taken into the compartment where the WC water is traveling. So hence you may require a separate pipeline in the shaft to take this water separately to the sewage treatment plant. Head and pressure, which is the level of water, the differential point of elevation is called where head of the water in the tank. H1, which is the lower head, which is having only small head between the water outlet and the the top of the water level. H2 is little more, H3 is little more. Higher the head, higher the throw of water. That is what we term it as kg expressed in terms of pressure, kg per centimeter square expressed in pressure. So height of the water increases, the pressure of the water is also increases. That is what the relation between head and water. This I have explained already. The indirect waste, we are throwing the wastewater directly with the air gap of minimum 25 mm. For example, maybe water from Bain Mary in a hotel situation. Water you need to drain off from the vegetable sink. So those pipes are connected just above the flow drain so that avoid the growth contamination of pipeline from the polluted water outside. Invert level of the pipe is the inner bottom of the pipe we call as invert level, which sorry, which you are frequently hearing from your plumbing consultant engineer as invert level of the pipe. Invert is the inside lowest point of the pipe. Rather, what we call crown of the pipe is the outside top of the pipe is the crown of the pipe. Set of laboratory basins, generally the height recommended is between maximum of 600 you want to connect through the maximum of 800 mm if you want to connect it through the same single pipe. That is where the arm length, which I have explained in the earlier slide, which come into picture. The larger the distance, you need to have a separate connection for individual wash basins. It is a codal requirement. So another this one equipment which we use is the macerating toilet system. For example, you need to have a toilet in the basement where you don't have any soil waste connection, direct connection, which can go by gravity. At that time, you can have a small ready-made available tank and with a pump which is connected back into the plug over there. Whenever flushing happens with the level controller, all that water go inside the tank, and the pump is pumping through the small diameter pipe outside at the drain line. So evacuation of water can be done without inundating any of the area here. These are good for retrofit kind of a work or in a basement situation. These are called macerating toilet system. So meter faucet, I will not explain further. This is one press which is giving a set of small amount of water so that the water wastage will not happen, and it is a sustainable kind of a fixture. One press, it gives small amount of water and it recoils back to stop the tap. So to adhering to the requirement of sustainability, the water saving aerator is one of the thing which we are frequently using nowadays to get certification under water credit, either by IGBC or LEED. Otherwise also it gives the 60% of the only water consumption. Your water bills are low and this is not costing anything huge amount. It also can be retrofitted, which are available. The retrofit, the aerators are available in the market, can be used in the older system wherever this type of saving you want to achieve. So earlier I explained on the wash basin, the overflow hole, which takes the water without spilling outside, and they have the internal arrangement within the bowl itself. If any excess water is impounding in the wash basin, which all allows through this one without inundating outside, it's called overflow system. Polybutylene pipe is another pipe which is used for water supply system in place of CPVC and other things. And multi-layer pipe, generally we call PE, aluminum PE, polyethylene, aluminum PE. In a section, cut section, you can see that there is a inner layer of PE which is carrying the water, and there is a adhesive layer, then the aluminum layer, then adhesive layer. The outer layer is PE once again. This gives little strongness even though you are bending the pipes. So this may reduce number of fittings more. The pipe can be drawn, bring it to the places wherever it is required. Unlike GI pipes, which is not bendable, quickly you need to use special fittings and fixtures. PEX is another pipe. This is called cross-linked polyethylene pipe. These are having a different properties of a hot and cold. It is a pipe-in-pipe system. The outer casing pipe is laid while just before the tile is being fixed. After that, the inner layer white pipes can be inserted in that. Whenever you find a leakage, only the white pipe can be drawn out, and the inner tube is well concealed within the wall. The other pipe replacement can be done. These are the little different pipe available, can be used in high-rise buildings or wherever it is required, so that installation of pipe can be addressed very well. In a plumbing terminology, we call plumbing fixtures, appliances, and appurtenances. We need to be careful in referring the things. For example, the plumbing fixture, water closet, we are calling as a plumbing fixture. And the plumbing appliance is any appliance which are fixed to the plumbing system, like geyser or water treatment plant. All these things are the appliances. So which is further gives a different product, either hot water or treated water or something else. So the appurtenances is like a backflow preventer or a assembly device. So these are the terminologies which we use as fixtures, appliances, and appurtenances. So generally plumbing fittings which we call as flushing tanks, the shower, four-way diverter, pillar tap, sink tap, ablution tap, all these are the plumbing fittings. Other kind of the pipe what we are used generally we heard in a plumbing system is PPR pipe, polypropylene random pipe. The joining is through the heat joint, so that the machine which is shown is the pipe is being heated here, and those heated pipes are fused together to the fittings here, the either T, elbow, or anything. So fixture is not by glue or something, but by heating the pipes. So which is addressing, those are addressing the hot water installation. PPR is considered as one of the good pipes. The
Sir,
sensor,
for interrupting you.
yeah.
Sir, we are running bit a short time actually. So can we wrap up in 3 to 4 minutes? I'm sorry for saying this.
Yeah, no issue at all. I'll do it in 5 minutes. Yeah, please.
Thank you so much.
Thank you.
Other kind of
The
the pipe.
sorry. Okay, these are the sensor faucet fitting proximity. It reduces the water consumption further there. The slope generally slope generally is the gradient between higher and lower, generally expressed as 1 in 100. That means to say 1 vertical to 100 horizontal. The thermostatic fixing valves, these are inbuilt within the system to control the temperature of water. The traps which are used for the avoid the foul air entering the system. Once again, the nomenclature regarding the continuous pipe, branch vent, individual vents. These are the battery of fixtures which we have shown as the different urinals with sensor fittings, which are arranged as per the plumbing requirement. The water closets, the particularly water closets and the few of the new urinals is having inbuilt traps here. This doesn't require further traps to connect these pipes. The touchless system, which is working half flush when you move your hand onto the right hand side, full flush move your hand onto the right hand side. Appliances are available. These are all developed during the COVID time to avoid touching of the equipment. The drywall installation is the toilet where extensively used to in the retrofitting jobs. These are the material of construction which are being used for water supply, stainless steel, composite, copper pipe, galvanized pipes. The material of construction used for the soil waste is SWR pipe, HDPE, DWC, foam core pipe. This you keep hearing from your consultant, plumbing consultant. Water meter is it is benefiting to the user where people only pay for the amount of water consumed. These are the sanitary fixtures fitted onto this. The fixing detail of IWC into the pan, which the separate traps are required because pan is only containing this one, which doesn't have the trap at all. So, particularly in a squatting Asian or Indian WC, you require a sunken of 450. That is what your plumbing consultant or engineer is asking to accommodate this trap. So, it is not his lavish requirement. Rather, he need to put the trap below the WC. Urinals with sensor fittings, different fixing details. Urinal with no water urinal. The cartridge is going inside the urinal, and the water, there is a yellow liquid which is not yellow liquid is the incoming urine which is coming here, but the outer layer is with the gel which is not allowing the foliar to come outside. These are the prohibited fittings here because the connection details are wrong. Stainless steel is being used because the coating of bacteria happens on the urinal system. These are the prohibited things which is not accepted. The prohibited fixture because from automatic flushing tank cannot be used for urinal stall because profusely water wastage is happening through this. These are the few decorative, the wash basin, the constructed details. Shower trays are used near the shower areas, either overhead shower or with shower trays. The connection detail of bathtubs, the whirlpool, the standard setting details, height. Thank you very much. I'm closing my presentation. I'm thanking the COA and IPA giving me the opportunity to give the this one integration and water sanitation program for blueprint of sustainability architecture. Thank you very much.
Thank you so much, sir, for the insightful session. The relationship between plumbing system, fixture choices, and a building's long-term performance is something every architect must internalize from the very first sketch. For question and answer sessions, my co-host Ayushi will take over from here. Ayushi, over to you. Thank you so much, sir.
Thank you, Prasanna Kumar sir, for such an amazing and insightful session. Each and every
Thank you.
participant here is grateful for you for your
Thank
informative
you.
and well articulated talk. So, with a very highly engaged and enthusiastic audience, let's now begin our Q&A session. Architect
Thank you.
Soumya Bansal asks that in the context of human-centered design, how can we transition from hiding plumbing in the shafts to making water infrastructure a visible strategic element that enhances occupant well-being?
I understand the requirement of the architect very well to hide the pipes, but hiding the pipes in the shaft where it may require frequent maintenance, hiding is not a concealing is not a good idea in the shaft where it requires the servicing. Whereas inside the toilet, we are concealing the pipe after proper testing, and there are junctions in the inside the toilet are very less. The toilet within the internal piping, either within the false ceiling or within the shaft, should not be hidden inside the structural element which is requiring a maintenance. So the shaft, we need to articulate that shaft covering detail properly. Nowadays, there are many FRP elements which are jalis are available to cover the shaft. Whenever shaft requirement, maintenance requirement is there, we are opening the shaft, opening the jalis and maintaining and closing this one. I understand that the aesthetics, but it is at the same time it is a requirement from the plumbing consultant engineer to address the maintenance issues.
Understood. Thank you so much, sir. So, can intelligent water systems be used for single residential dwelling units? And if yes, would it be feasible?
Yes, intelligent system can be used for this one. Intelligent system can be anything from water supply. For example, you can have the automatic the sensor based system which uses less water, sensor taps which uses less water, or the use of IoT based things which is filling your tank from underground sump to overhead tank. So there is no wastage of water. Even doesn't require any manual intervention, or the intelligence system to collect the used water. And there are portable small STPs even to the tune of 1 kL which is available, can be treated well within the individual house, and treated water can be used in their garden or used for washing purposes. So intelligent system can be miniature for individual building which are available, can be used.
Understood. So, Kalpana Kavetkar asks that in case of high turbidity of water, can we have precautionary measures in terms of materials and systems layout for plumbing?
See, one is the plumbing itself may not taking care of any colored water or turbid water. It just water travel through the piping system. The turbidity water need to be controlled at the source itself. One is municipal. If municipal is also bypassing and you will get the turbidity water to your underground sump, then store it in first compartment of the turbidity water. Use normal sand filtration system and pump that water to other sump or overhead tank directly, and use reticulate that water into the plumbing system, so that plumbing system at the downline is safe, and your the turbidity water, you will not consume that water through your plumbing water mains.
Correct. The architect Shereen also asked if you could share approaches that are mandatory towards the efficient use of water in daily life, in the background of increasing water demand.
See, now National Building Code of India is also revising now. What we have is 2016, I believe, and it is being revised. There are many new things are being added in terms of sustainability and reduced water demand. That is what we know, because IPA is also working closely with the revision of Indian Plumbing Association, National Building Code of India, and giving the suggestions which are required for the sustainable approach. There they are reducing that any time that code will be revised. And there are many appliances which I have already shown, aerator and all these mechanisms can reduce the water level. Even it is costing about less than 100 rupees for a tap, for a efficient this one. Even ordinary also it is about 50 rupees, can be replaced, used for the efficient reduced water demand into the system. Yeah.
Understood. One last question I think that we can take for now. For water-centered design, what are the technical benchmarks for transitioning from centralized city supply to decentralized building level STPs without increasing the building's energy footprint? And do we strictly need to follow these all benchmarks while designing for plumbing?
Okay. This the STP system, centralized, decentralized, is very subjective to the project. For example, if I am doing a 100-acre project and project envisaged in phases, and I cannot do the centralized STP at once, only because I am reducing the energy consumption, or that time the decentralized may be addressing. So it is a many parameters which we need to consider to make it to address, or centralized with compartment thing which increases little initial investment of your structural thing, but you are reducing the energy consumption. That also be partially centralized, but it is a decentralized whenever the different phase of sewage is entering to the system. The same applicable for water supply system, same for the sewage system also. So it is very subjective to the project. Everything can be aligned to the sustainability and less use of energy and carbon footprint, water footprint, every possibility is there. We need to define it much before onset of project.
Thank you so much, sir, for addressing each and every question so elaborately. Once again, we are thankful for this engaging and enlightening session. Over to you, Shrutika ma'am, for further coordination.
Thank you so much, sir. For a very quick note for all the participants again, this program is being live streamed on YouTube. Participant must write their attendance with their name, designation, affiliation with college or offices in the chat box session wise. Questions should be posted in between the sessions for Q&A session. The feedback link be active for only 15 minutes after completing the 4 sessions, and the certificate will be issued upon successfully submission of the feedback form. Now, it's now moving towards session 2. If session 1 gave us the foundation, session 2 takes us deeper into the arteries and veins of a building. Every living organism depends on a circulatory system, one that delivers with what is needed and removes what is not. A building is no different. Water supply principles demand estimations, distributions, hot water systems, sanitary drainage, taps, venting, and odor control. Together, these form the invisible yet vital network that keeps a building truly alive. Our speaker for session 2, which is the arteries and the veins, will help us understand how a seamlessly integrated water and waste system is not just a technical requirement, it is the hallmark of excellent architecture. It is my privilege to introduce Sri Sharat Veerao sir, a leading voice in plumbing engineering and integrated building systems, whose work has profoundly shaped how the profession approaches water infrastructure design. We are honored to have him joining us on this meeting today. Sharat sir, a warm welcome to you. Over to you, sir.
Thank you, Shrutika. Uh, Good afternoon to all. I first share my screen. Is the screen visible?
Yes, sir, it is visible. You should.
Uh,
Yes,
yes, sir.
yes, it's visible, sir.
Perfectly visible.
This is perfect. Okay.
Yes.
Good afternoon to all, and thanks for the lovely introduction. The session, the second
So
session
you
now.
can so you can click on the hide button on this
Okay.
pop-up.
Okay. Yeah.
Yes. Wait.
It's titled as the arteries and the veins. I think it's one of the most apt title for this session because the arteries and the veins are blood vessels. The arteries are thicker, the veins are relatively thinner, and they supply blood to each tissue and organ of your body, and also In the process, through the veins, the impure blood is also collected and the same is reprocessed. This particular thing also applies to water and sanitation because both water and sanitations are, water especially, is very much required for life's existence on this earth. Now, I always say that wherever water ends, drainage begins. These two things, instead of complementing each other, they even supplement each other. That is, water today is a very, very depleted source. Now, all these years we have been talking about climate change, carbon neutrality, and suddenly, if you see over the last 2 to 3 years, the whole focus is on water. To the extent that people say that wars will be fought, although that is a little far fetched, but it is true that water is becoming a commodity which is getting scarcer and scarcer day by day. You know the reason why water becomes so important? Among the Panchbhutas, water and air are two important elements for our existence. Air is all around us. Of course, you need to treat air. Otherwise, if you are living in Delhi, you may suffocate. But water is one commodity which cannot be manufactured. That is why it makes it more precious. The only way where you can get water is from the skies to open up. It rains, it comes down on Mother Earth, and you are able to get this water, which gets hidden in the form of glaciers and snow in the mountains, and which keep on giving the continuity for feeding the water. So, ladies and gentlemen, the architects and the engineers together have a tremendous responsibility on their shoulders to see that we make our country water positive. What I mean by water positive is not water neutral. That is how much we spend, we replenish. No, we have to give back much more than what we are consuming. And this can be done, and we will see through the session that there are ways and means to do it. Now, what is the basic, simple definition of water supply? It is a system by which water is sourced, treated, and delivered. So it involves, most important, you need to collect the water. After you collect the water, you need to treat it to meet quality standards. And then you need to distribute it through a network of pumps and valves. And in the process, these become the key components for defining your water supply. First thing is, for any project or any building to be conceived, the most important thing for you to see is that whether water is adequately available and whether the source is a perennial source. What I mean is, it should not be a depleting source. It should last till the life of the project. So you need to estimate the daily water requirement. You need to identify the source. You need to test the water to get the quality of the water. Then you need to store the water and then distribute it. And then, of course, the needs vary from region to region. So hot water will also be required, which is again a different story altogether. Now, what are the main primary sources of water? Most of the water, when you stay in urban areas, it comes from the municipal supply or the bore wells and the water tankers. And water tankers, what I mean is not a regulated supply, which is to be bought out. Another source, which of recent over the last 10-15 years has gained a lot of importance, is rainwater harvesting. And in that, whatever water you collect on the rooftops of your building or the constructed space can be made fully available for beneficial use. The third and one of the most important source is the treated sewage recycled water, which is also called reclaimed water. And generally, it is being used for landscaping and flushing. But if need arises, you will be surprised to know that you can treat this to a level that it is made drinkable. Now, as I said, that once the source is identified, you need to treat the water. So, before you treat the water, you have to sample the water and send it to the laboratory for testing. It's a simple testing procedure which takes about a week's time, and these laboratories are spread all over the country. And generally, you will adhere to the Indian BIS IS standard 10500-212, which specifies the drinking water quality standards in India. And if you need further reference, you can refer to the World Health Organization guideline, WHO, which talks about global standards, which are to a great extent aligned with our IS. So if you meet 10500 requirements, I think you have done a good job. Now, basically, you will have to meet three standards to make the water fit for use: physical, chemical, and microbiological parameters need to be tested. Now, here is not a comprehensive list, but I have filtered it down to some of the main uh, parameters which need to be sort of analyzed in the lab. Uh, of course, it depends on what is the end use of water, how pure you need it, which will define more parameters. But basically, as I said, the physical attributes will define the pH of the water. And what is pH? It tells whether your water is acidic or whether it is alkaline. The lower range, 6.5 and below, is the acidic range, and generally 7 and above is the alkaline range. So ideally, you should keep it should be between 6.5 and 8.5. The next is turbidity. Is just, I think, one of the delegates had asked about turbidity. This is also very important, especially you will find turbidity means the water is murky. It looks brownish, and mostly it will be prevalent in waters which are drawn from the open well or from open surfaces. River will have turbidity. Very less chances, but still could be possible in bore water, since you are going down hundreds of meters to draw the well water. The third one is the TDS. It's called total dissolved solids. It defines the salt levels in the water, which is very important because we have restricted it to 500. But generally, for drinking in metropolitan cities and for a drinkable level, it should be around 200 to 200, which makes it more palatable. But 500 is tolerated. And in the chemical, the hardness will be very important parameter especially if you are go 2 points. One is, if you the more hard the water, the more soap you will consume, which you have learned from our school days, the lather. But most importantly, in a project point of view, is if you are going to use the water for any cooling or air conditioning purpose, you need a much, what you call, commercial zero hardness water, which is less than 5 milligram per liter. Now, generally, you will see milligram per liter, or sometimes it is written as ppm, parts per million. Both units are the same. Chloride, sulfide, nitride, fluoride, iron is all uh, metals which should not, can be present to a certain amount. Toxic elements, arsenic, lead, arsenic, mercury, there are many, the list is long. Cyanide, you would be surprised that generally it is not found in water uh, which we use, but this could occur in a source, especially if that was an abandoned factory, an abandoned radioactive unit, because the soil can contain these elements and which should not be present in the water at all. Most of the time, it is that water has to be discarded. And the last one, the microbiological, the E. coli and the total coliforms, absent, and it's 1 per 100 ml. Sorry, there is a mistake over here. This E. coli is what defines how pure your water is for your stomach. More the E. coli, you will be the victim of jaundice. And I regret to say that we lose thousands of young born children to gastroenteritis, enteritis all over India, especially during the monsoon days. It is because of this rogue element, E. coli, which is there in the water. Now, how do you go about this water treatment? First thing is, you have a common water treatment unit for the entire development. If it's a single building, you can have it. It can be located in the compound area of the building if space permits. Otherwise, most of the time it is tucked within the building line. And the processes which are important are filtration. And of course, if there is turbidity, you will need something called coagulation, wherein you add alum sulfate salts in the water to coalesce the water to make it come together, all the solids, and then you sediment it out. The other one is the normal filtration and the disinfection, which is done through chlorination, nowadays ozonation, or UV radiation, that is UV filters, or it can be done. The whole process of treating water can also be through RO treatment. Now, this RO treatment, reverse osmosis, is sometimes very, very sort of loosely used terminology, and many times it's not required. This is only if your water is brackish, that it contains very high TDS, more than 600, 700, coming around to 1000, then you need these RO treatment units. Otherwise, RO is not at all required, because RO, remember, involves a lot of wastage of water, because the reject water, because in an RO, generally when you treat 100 liters of water, only about 60, 70 liters get into beneficial use. The other 30 to 40 liters are sent out as waste. And the waste which comes out is super saline. It cannot be used for anything. And disposing it off is a huge headache. And the next one is that the common household units, You have these RO units, UF units. You see plenty of advertisements on your televisions who advertise for these units. These are good enough to keep it in your kitchen for your drinking water. Water demand estimation. Basically, we follow in the country the National Building Code 2016, Part 4. But in many times, you need to follow the local statutory authorities like the municipal corporation or the Gram Panchayat if it is more in the smaller cities. As an example, typical water requirements are in the residential 135 liters per head per day, and now the revised code perhaps may bring this down further down to 105 to 110, but still the notification has not come, so not sure about it. But ideally, we should be getting it below 135. Office buildings is around 45, but in our experience, when you do projects, we see that this is also an overkill. It should be reduced to 30 to 35. Restaurant 70 liters per seat. Hotels up to 3-star 180 liters per day. And hotels up to 5-star 450 liters per head per day. Of course, in these hotels, the kitchen, the other peripherals like uh, restaurants, the class of the restaurants, all need to be considered before you come to the correct water demand. So, in simple terms, the total population of the development into per capita demand will be the total demand that the water that will be required. Now, once you have determined the source, you have determined the demand, you need to store. Why you need to store? Because of the simple reason that we are supplied, especially in cities, or I think most of India, in fact, except for a few cities, smart cities, which are coming up now, we are having an intermittent supply of water. We don't have continuous supply of water. Once you go to the developed countries in the US and most parts of Europe, you don't find individual storages underground within the building premises or within the built environment. That is because they have adequate pressure in the line, which is just boosted and supplied directly to the residents. While here we have storages, these storages can be located in the building courtyard if you have space, once again, if you have space. Otherwise, it goes into the basements. And once it goes into the basement, you have to be very alert when you are planning this because when you hit a basement, there are many elements which need to be considered, and among them, water tank happens to be one of the most important uh, entity which has to be given due consideration, and that is why one of the plumbing professionals should be immediately involved. Otherwise, there is a way of constructing these tanks. They have compartments. For example, fire storage. We are not dealing with that in this presentation. And then you have the domestic storage and the flushing storage. And I have given the word something called flushing storage with sanitary separation. This sanitary separation is a wall between the domestic and flushing storage. Is not a wall, it's a gap between the walls, generally of about 100 mm, which is then filled up with filler spaces. But this gap is maintained because most of the times, because of the environmental considerations, because of sustainability considerations, treated recycled water is used for flushing. And over the years, this can seep into the domestic water because even after treating, the level of water in the flushing tank is not to the level that it can be used for drinking or for domestic purpose. It's good for flushing. It's good for landscaping. So you need that sanitary separation. So basically, there are three places where you store: underground, overhead, and intermediate or transfer storage tanks when you're dealing with high-rise buildings, which you will see in the subsequent slides. Now you see a diagram of a water tank, typical. See, you have about 12 different things coming into the tank. All these need to be addressed at the planning stage. Otherwise, what will you land up is you need to put the sleeves, something called, it's called puddle flanges, so that you don't puncture the water tank walls, especially if it is in the basement later on, because leakage in the basement, very, very difficult to stop it. So this is the typical uh, story of every building. You have a low level tank which is mostly underground and a high level tank which is on the roof, and you have a pump and you keep this is which is on an auto mode, and you there is a continuous supply of water to the residents. So the intermittent supply becomes continuous supply through storages. Nowadays, there is an advent of these types of FRP tanks which have come into vogue. Uh, this is one picture from a site. You can get for any capacities. These are fiber reinforced plastic tanks which can be brought and assembled on the site. Most of the time it is bolted, and there are stainless steel bolts, various type of anti-corrosive bolts. By this, the construction is faster and the water quality remains better because concrete is porous and can breed bacteria in a later stage. Now, once you're stored, you pump the water, it's time for distributing this water. Basically, there are two major systems, that is the gravity system and something called the hydropneumatic system, which is nothing but a pressurized system. Simple gravity system, as I said, there is an underground tank, there is an overhead tank. From the overhead tank, there is a ring main which runs on the roof, and you feed it to your toilets and your kitchen. In the hydropneumatic system, this uses pressure pumps and compressed air tanks to maintain constant pressure and supply water at that. Here, the change between these two is that there is a underground tank. So all the capacities that you have worked out is stored here. While in a gravity system, these capacities are distributed between these two places, these two sources. Generally, you keep about 1.5 to 2 days capacity. So they are distributed, while here the entire capacity is stored underground, and you directly pump it through these booster pumps. The booster pumps are something like this. It has a pre-charged diaphragm tank with it. It's called hydropneumatic, but actually there is nothing pneumatic. In earlier days, there used to be an air compressor, a big paraphernalia used to accompany. But these days, you got this pre-charged diaphragm tanks, which, with through a pressure switch, activates the pump and keeps it on an auto mode, on and off. And you supply directly. You will see a little bigger picture of all this. Now, this is a typical drawing for a water system by gravity. You have this pump, you have a main, this is for a huge development, say for 4 blocks. You have a pump main which runs along the building line, enters into the shaft of each building, delivers water into the overhead tank. Then you have a loop main or a ring main which runs on the top roof. This is to equalize the pressure of the water when it is being supplied to all the shafts in the building. And then you break the water into these gravity zones. Generally, we make it into 5 to 7 floors per zone, and we do the piping distribution. Similarly, it goes on for this. These pumps, even though it is feeding these 4 tanks, it can still be on an auto mode with motorized actuators, and pressure switches for auto control. The same thing now, 4 blocks on an hydropneumatic system. Here we have, like the gravity, we have divided this, since it is, I think, a 19 floor building, 19 or 20 floors building. We are divided into 3 zones, 1, 2, and 3. So we have 3 sets of pumps for each zone. The lower zone is fed by one set of pump, the middle zone the second set of pump, and the third zone by the third set of pump. And these pumps are feeding all the blocks. There is no overhead tank here. And direct pressurized water to whatever pressure you need can be delivered to your remote stand. Of course, to make the sketch simple, there will be a lot of pressure reducing walls in places, because you can't deliver water above 4 kg pressure anywhere. So you need to bring down the pressure if the pressure goes above that by pressure reducing walls, which will be put in these distribution pipes. This is a typical combination of what I had earlier referred to, intermediate stage tank. In fact, Prasanna sir had also shown 2 beautiful buildings, one with a hotel at the top and an office building, multi-use building. It's similar, but this is a purely residential building. It is about 60 floors in height. This building is with the high-rise, is with this break tank. The earlier sketch is that the same building, you could have put it on hydropneumatic. Then you would have had plenty of pumps over here. 3 pumps for this zone, another 3 more pumps for the next zone. So it would be a battery of pumps located down. While over here, you break the building vertically on every 20 floors. It could be even 15 floors, 20 floors, but you will have to work out the pressure calculations to find out exactly where you want to locate these tanks, which are called break tanks. So this has been kept on one at 20th floor, one at the 40th floor, and one at the 60th floor. So you have the same logic. Tanks below. The tank pumps water to the first stage tank. From the first stage tank, there will be pumps over here. It will pump to the second stage tank. While there is another pump over here which takes it to the thing. Similarly, the whole thing is on a relay. All the 3 break tanks are being serviced from here. And then you supply the relevant zones by gravity from these. So this reduces your power requirements. That is, otherwise you will be pumping all the way right up to the top. So you have broken the pressure zones vertically, and you have drastically reduced the power requirements. Otherwise, what would have happened? If suppose you don't want to use these tanks, or you don't want to use multiple pumps, theoretically it's possible that you put one huge pump over here, pump it to the top, and bring it down with a conglomerate of pipes, walls. In this, you may reduce space, you may reduce the height of the building, but you are entering into extensive energy and extensive reasons for a breakdown. Hot water distribution. The hot water distribution generally in in buildings, residential buildings, smaller buildings, still what is in vogue is these electrical geysers, because gas heaters are expensive and they are not so much used. So there's are those instantaneous electrical water heaters or the storage type electric water heaters. You have this gas-fired instantaneous water heaters, gas-fired storage water heaters, but these are very rarely seen in metropolitan cities. These are oil-fired water heaters which are not nowadays being used much. Maximum emphasis these days is being given to solar hot water systems and heat pumps. Heat pumps is a recent development. It works on the reverse of an air conditioning cycle. So you take air as a medium and it's heated, and through condenser and other such type of contraptions, hot water is generated and is directly supplied to the residents. This is also supplemented with solar water. As long as the sun is shining, you will get solar, so you will get tempered water, and the heat pump is sensitized so that it comes on only when the thermostat says that it has to start working. So that's why it's the ideal way to conserve energy. Nowadays, you get heat pumps, storage type also, which you can use it in the buildings internally. You can have perhaps one single, if you can plan the resident properly, one single hot water storage heater supplying to all the toilets in a house. Now, the materials which we generally recommended are CPVC pipes with insulation, copper pipes with insulation, PEX pipe with insulation, stainless steel with insulation. This is the typical insulation, and insulating the pipe is a must, even for shorter lengths. Many times this mistake is done on sites that you don't insulate the pipe. You think that the plastic pipe doesn't get heated up, CPVC. But there is, if you touch the pipe and after the insulation, you'll see the warmth, and this can lead to your tile cracks and other things. Generally, the insulation use the nitrile rubber. Glass will very rarely nowadays, but more of nitrile rubber in built environment. Water efficient plumbing fixtures. Now, I said in the beginning that water has become a very precious commodity. So, it will be very prudent to reduce the consumption at the source itself. Because once you reduce the consumption at source, it's a double hit with you. You're reducing the water, you're reducing energy. Because when you reduce water, you have to pump less water, you have to treat less water, the drainage that comes out is less, so your STPs and everything is downsized, and it's a win-win situation. There is an IS code 17650-2021, part 1 and part 2, which defines what are the water efficient plumbing fixtures. The Indian Plumbing Association has also developed a guideline called WEPI, Water Efficient Product India Guidelines, in which you have, this is there even in the IS 17650. dual flush systems, flush walls, wherein it is 6 liters full flush and 3 liters half flush. This is another type of water closet called high efficiency models, in which there is less than 4.8 liter for full flush, not much used in here. Urinals will pump 3.8 liter per flush. I feel it is still more. It should be brought down to about 2 to 2.5. But you have waterless urinals in the commercial environment, which doesn't consume any water. Then you need shower heads. The flow rates are 9.5 LPM. Earlier, these shower heads without this contraption would deliver not less than 15, almost 20 liters per minute. So you can imagine what a wastage of water. Faucets, that is the taps, 8 liters per minute. Even the kitchen sinks are also 8 liters. This also you would never deliver less than 15 liters. And we have monitored and seen you can have a saving of almost 50 to 60%. It is nothing but these are those nozzles, aerator nozzles, which any plumber can fix it in your tap, which allows a mixture of air and water, which doesn't reduce the cleaning, cleansing comfort, but reduces your water intake. Water meters. This is one of the most crucial components in a water supply. These water meters, you have we have a bulk water meter which is kept once you enter at the entrance of the building, which reads the total water consumption. And nowadays you have this ultrasonic water meter, electromagnetic IoT based water meters, all cloud based, which will help in real time monitoring. In fact, these are also called smart meters because they use sensors and connectivity technologies. In fact, what is advocated today is that every house should be metered, just like every house has an electricity meter. And that is why we are mindful of the electricity we spend because we pay for it. Similarly, if you want to conserve water in the real sense, every house has to be metered. This is greatly in practice in lots of areas in Hyderabad and Bangalore. I come from Mumbai trying to push it, but this needs to come as a requirement. And herein, the architect and the plumbing consultant need to work in close coordination. That is, you have a water meter at the entrance to an house. These water meters have to be installed and forgotten. All the readings, everything will be taken, all app based. So every day, if you want, you can get how much water you have consumed. And you can see whether your son, your daughter, or whoever is consuming a lot of water or wasting water. Color code for identification of pipes. I won't go through all because of paucity of time. But here, this color coding of pipes is very, very, very important, especially with the potable water, light blue, and it's all given in the code as to how the lettering has to be used, what color should be the lettering. Recycled water is almost a dark purple, and raw untreated water, if it is from the wells, is dark blue. Now, I would like to give you a glaring example over here. It has happened in one of our projects. Now, for example, in the duct, there are pipes running. One is getting you water, drinkable quality. The another pipe is your flushing water, which is come from your recycled water from sewage treatment plant. Now you bring a washing machine and you install it, which happens maybe after 1 or 2 months after you occupy the flat. Your main plumber is not there, so you call the local plumber. He sees that there is a flushing pipe running very close to your machine. He will tap it from there and connect it, or even to your dishwasher. And you can imagine what will happen to your health. That is, you are drinking contaminated water. So, this coloring of pipes should be done in every project. For all the pipes, there are different colors. This to be used. Material of construction, the first three and pipes are all plastic. Again, you have PPR plastic and PEX. PEX, that is, Prasanna had touched upon this. Polyethylene cross-linked is a polyethylene pipe, but it has been cross-linked. The composition has been changed. Polymers have been added, by which it has been made more heat resistant, and it has been given a flexibility. It is something like this. The pipe, these are the fittings. So these are bendable. So you run it. This is an adapter which is kept in the shaft or in the ceiling of your house, from where you can take the tappings for your domestic, your flushing, for your hot water, whatever. This is a multi-layered pipe which has PEX inside, PEX on the outside, and a layer of aluminum in between to give the rigidity to the pipe. So these are those adhesives which stick the aluminum to the plastic. They are always, most of the time, they have a crimp joint. So making a joint hardly takes a minute. If anybody is interested, this is a typical PEX piping layout. It's just like an electrical conduit. You have that adapter over here. From here, you runs these pipes. It can be from your ceiling or it can from your underfloor to your fixtures directly. Directly. You need not go through all that bends, fitting, nothing. The advantage is, tomorrow if there is a leak or something in this pipe you want to remove, without dismantling anything, just from this adapter, you can pull out that pipe through its sheath, insert the next one, and of course you will need a trained plumber to do it. Abroad they do it themselves, do a DIY type. But this has been being used a lot nowadays, especially in hotels. Now we come to the next part, that is the sanitary drainage. There are basically two types of major systems in sanitary drainage. As the name suggests, one pipe system, two pipe system. In one pipe system, there is one single drainage pipe which carries the liquid. That is that sewage downwards. And there is a vent stack which carries air and gases. So ideally it's a two pipe, but it's called one pipe because there is a single drainage pipe. The other one is a air pipe. In two pipe system, there are two pipes. One is the soil pipe, one is the waste pipe. And again, there is a vent stack which carries. So two pipe system is ideally a three pipe. Soil pipe is a pipe that carries the dirty waste, that is soiled waste from your water closets, urinals, clinical sinks, or fixtures which has a biological load. Okay, that is which contains bacteria in its discharge. Well, the waste pipe is one which is free of fecal matter and it is more purer than the soil pipe. It includes waste from the showers, bathtubs, and wash basins, which nowadays is called grey water, and the soil pipe water is nowadays called black water. Now, this is also a late ongoing trend. This is a single stack system in which there is one single stack, was a one pipe system, And there are subtle variations to this single stack system. But one of the most important thing when you use a single stack system is that you will use a sanitary T or a bed, or what is known as a swept T. This is not a right angle T. The T is made in such a fashion that it allows the water to flow very smoothly through the pipe. And in that stack system, solvent system is an erector fitting which is fitted in the stack system, which makes the flow of water, flow of discharge much more smoother and much more better. What it does is the design of the solvent ensures the branch, soil and waste pipes to discharge into the stack without any disruption and keeping the central air core intact for the air to move. Now, friends, in any drainage pipe, it doesn't run full. A drainage pipe runs only about 33% full. Rest of the 67-70% is full of air. This is the typical solvent. These are the points, there are about 6 over here. You can connect your soil pipe here, the waste pipe here. So automatically the upper floors, the water is flowing straight. The connected floor, water comes here, follows its own path, and that is how equilibrium is maintained. Traps. Trap is a very important component because this prevents foul air and the odor from coming in. It also prevents the vermins, cockroaches from coming in. Basically, it has a water seal, and this water seal keeps the system in equilibrium because there is air pressure acting on this. And it's always, now in the next sketch you will see, it's always recommended to use P traps. P traps, preferably with a 50 seal, should be used. You might be seeing that most of the projects, what is being used is that bottle trap. The bottle trap looks good. You have the chrome variety and all various fancy bottle trap, but it doesn't have a real water seal. So it's really not acting as a trap. This is also a trap, but you have to be careful how much length you use of this trap because it can, because of the pressure over here, it can push the seal out. You also have nowadays the grease trap, especially if you are doing kitchens, commercial kitchens, not in the residential area. The grease trap is good for trapping fats, oil, and gases. Grease, not gases, sorry. That's called fog. Here is the ready-made grease trap. There is an inlet, there is an outlet. You get something which you can keep it under the counter, connect your drainage pipe, your sink to this. The grease and the fat, being lighter in weight, will float in the top and which can be periodically cleaned. In commercial kitchens, almost every day it has to be cleaned. This is for large scale establishments. You can construct a grease trap in concrete. And here what you generally have, an access cover, and you have, I have not shown it over here, you have an aluminum basket or a stainless steel basket. You just lift the basket and the water flows down because it is jali and the grease can be separated out. The grease creates havoc in your pipe because once it becomes cold, it solidifies and all the chokages happen. Indirect waste was also touched upon in the last session. Indirect waste piping shall discharge into the building drainage system through an air gap or air break. I will explain it through a sketch. Air gap is, that is, wherever the discharge comes, you will not connect it directly to your drain. You will discharge it through an air gap of almost 25 mm, 1 inch. This is again, this is a drainage air gap. This is the water supply air gap, wherein your tap has come here. If your tap had come below, then there is a great chance that if there is vacuum in the line for some reason, all the contents of this will be back siphoned. Similarly here, if you connect it directly, if there is any negative pressure in the line, these contents can be sucked back into the thing. So this is the scullery sink, very much seen in all hotels and commercial kitchens. This is connected. How it's connected? There is a drain down and you have brought the discharge pipe 1 inch above and is discharging freely into this. It should not be connected directly. Herein you can put an under counter grease trap and it serves the purpose. This is a typical manual sketch. I won't go much into detail. Nowadays you get precast manuals. In PVC also you get it. You get it in RCC also. These are precast 1 meter or 2 meter length, depending, which you can directly, it's a tongue and a groove arrangement. So on this tongue and groove arrangement, there is the groove and the tongue of the next piece will sit into the groove. You can keep on adding it up and a manual is created. Only the top one, you will have to cast it in situ to bring it to your own formation level. Same thing can be available in RCC also. And these are something which you call toilet pots, prefabricated. These are, I just wanted to apprise you of these new developments. These are prefabricated toilet. What you see over here is a toilet which has been prefabricated and set up somewhere far away. It could be, it is not on cast in situ. This is maybe in a yard. This is done. This is then carted away to the site, transported. This can be even taken to the 30th floor. Height doesn't matter. And brought in place and installed. This, and these are the PEX pipes which are helpful. And these are also then, there is a drainage pipe which can't see over here, which can be connected to your main building drainage directly. So these are rolled into place and placed over here, including the waterproofing is also done. So it's a perfect fit, a fantastic modern development, but of course expensive. But if you are thinking of fast-paced constructions, these are being done. These are not something from the net. This is being done. Many projects in Pune has been done, Hyderabad, Bangalore, in many places. They are called toilet pots. Sewage treatment plant. Nowadays we talk a lot about water circularity everywhere. It has become one of the major sustainable word or a jargon. This all is that you convert the waste into a resource which can be used. For that, you need a sewage treatment plant. I'm not going into details of a sewage treatment plant because it can take a full day. But one of the major technologies which are used are extended aeration, with or without media, sequential batch reactors. As the name suggests, you can treat it in batches. Membrane bioreactors, MBR, which is very sensitive. They use ultrafiltrate membranes or RO membranes to filter the sewage. and can produce water of drinkable quality. And nowadays there's something called phytoremediation, which uses plant and the soil to treat the sewage, in which you need storages, but you don't need any power over here much, except for pumping the sewage. No air required, nothing of that sort. But you need extensive areas and open areas. This is very much done in T2, T3 cities today. Most common one is the acceleration with or without media. It is generally called a moving bed bioreactor, where you have a floating media going around, and this this is the basic planning for plumbing. I think, Shruti, how much time do I have?
Sir,
I think I've come to the
with 2 to 3 minutes left. More.
like my earlier speaker said, I would urge the architects to be a little more generous whenever you are giving the shaft requirements, because this happens to be the heart and soul. There should be enough space for a person to move in. And you can see today the number of pipes that can come in. You have a vent, then you have a soil pipe, you have a waste pipe if you are not using one pipe, then you have a recycled pipe coming over here, you have a solar hot water system coming inside, and then if you have a condensate pipe, if it's air conditioning in a commercial building, one more. So you have a plethora of pipes running over here on brackets, and these need to be kept away from the walls, preferably at least 2 inches, 50 mm. Otherwise, you can always find the dampness on the walls. So all this requires space in the plumbing shaft. It's always better to locate the shaft as close to your fitments, because that will reduce the pipe lengths. It will reduce the chances of your leak, because nowadays there are two ways of doing the internal plumbing. One is the traditional sunk, wherein you need a 9-inch to 12-inch sunk to accommodate all the pipes. Otherwise, you can go suspended below the slab. But all this, if you keep it close, it's better. These are some of the mounting heights which you need to follow. And these mounting heights are is available in all the codes and in the books, but these need to be adhered to. So I believe I have stuck to my time. And I would like to thank you all for hearing me out patiently. Thank you very much. And I would like to thank COA, Dr. Rashmi, and the IPA for having given me this opportunity to reach such a wonderful audience. And thank you again.
Thank you so much,
Thank you
Sharat
for
sir.
the.
You can continue, ma'am.
No, I just said thank you, sir, for your time and session. It was wonderful.
Thank you, sir, for that richly detailed and enormously valuable session. The message is clear: water and waste systems must be designed as one integrated whole, not as afterthoughts added at the end. For question and answer sessions, my co-host Ayushi will take over. Ayushi, over to you.
Thank you so much, sir, for such an informative and illuminating session. Thank you for sharing with us the prudent measures, strategies, and concepts which will definitely make sure that we successfully tread towards becoming a water positive nation, as mentioned by you. So the chat box is flooded with curious questions from participants all over the country. Let's dive right on in. As mentioned initially by you, how ROs waste a huge amount of water, and presently all residential units, be it bungalows, high-rise buildings, apartments, they all have installed RO systems. So, what is the alternative to the usage for RO systems, and how can we limit the wastage of water from these units?
Uh, in fact, wastage of water from RO is a very given thing. The latest RO techniques, I'm being told, is they have been able to bring it down to 20% to 25%. I don't know how far it's practically correct, but these first thing is, as I told, please don't use RO if the water quality doesn't demand that. If the water quality you don't have very high TDS, you don't need to go in for an RO. Any of this filtration, even those cartridge filters and a UV filter is good enough for your water. But the disposing of an RO, especially if the water is having very high TDS, more than 1,200, I would say it's very unfortunate that you have come across such water. But it's a big problem to discharge RO waste because because you can understand the waste is just 20%, 80, whatever, 30% or 40%. In that 30%, 40%, all your salts are put in, which are there in the water. So you can understand how saline the water has become. So maximum is you can discharge it into your gardening if your plants are able to tolerate the salinity. Otherwise, there is no. There are methods like flash evaporators and all. They are so expensive, so big energy hustlers that it's not not meant for in most of the places. People get it carted away, but it should not be discharged into stormwater drains or something, concrete, because it will eat away the concrete.
Thank you, sir.
Sarath sir, if you could stop your presentations so that you can be in the
Oh,
center.
oh, sorry. Where is
Then minimize this window, go back to the meeting window, and stop sharing from there.
I'm not getting the stop sharing. Oh, yeah, yeah. Is it gone?
Yes, sir. Yes, sir.
Yes,
Oh,
sir. Perfect. Yes, sir. So many participants also ask how these water demands are estimated and how can we reduce it. Along with that, which is the most effective treatment method to get the maximum amount of recycled water for use in both cases, residential as well as industrial.
residential.
I think Sir left the meeting. Maybe we can connect with him once again to ask him to join meeting again.
I'm just calling
Rohit
him.
ji, please check.
Yeah.
I'm just calling him.
Meantime, can I take that question? Yeah.
Yes,
Sure,
sir,
sir.
Meantime,
please.
just to
Definitely.
appraise till he join,
Definitely.
probably how do we estimate the amount of water? That was the question, I believe. Estimation of amount of water is either the end user is knowing, for example, hotel or hospital or something. If something is not known to us, there are National Building Code of India, Uniform Illustrated Plumbing Code of India. All these defines on activity basis how much to consider and also gives how much population we need to consider. So both the things, if you multiply population with this one, you will get the quantum of water used for that particular project per day. So that gives a fair estimate, and per se for a practicing engineers like us and the architect who are sitting there, they also knows that those amounts are not going wrong. Because that is all code is written after all that estimation and thorough investigation. So that is the best method to adopt. For example, hotel wise, there is a differentiation. Even code says something, and actual hotel operator knows they are using lot of water. At that time, they give the water demand. They say my guest room requirement is 350 liters for this purpose, for banquet this purpose, or something this purpose. At that time, we take their estimates.
Understood. Thank you, sir. Sir, also it was asked that what is the most effective treatment method to get the maximum amount of recycled water for reuse?
There are, Mr. Sharath has explained about 4 types of different treatment. The conventional activated sludge process, there is a MBR technique, there is a SBR technique. All techniques are the cost dependent. One is the capital investment cost, another is the replacement cost. We need to carefully choose. For example, I am just taking a hotel. You just can't have the treated water with the pale color or something. This one, guests may not agree. Guests absolutely they don't agree on the color of water and all. But still, we need to practice the sustainability aspect. At that time, MBR is a better technique which gives a absolute crystal clear water, but at some cost. So those are the parameters we need to choose. There are housing areas in class A, class B cities where activated sludge process is a better system. Even it is good for our metros also. Those systems which are civil intensive but maintenance friendly. Means we need to pick and choose the type of treatment that your consultant will advise on based on project to project, and the phasing is also important. So some STPs you can't treat less than 50% of capacity of STP. Some STP you can treat up to 20% of the whole capacity. On inception of the project, you have very less sewage, STP will not run. So all these parameters you need to consider choosing a particular kind of STP.
Yes, definitely. Completely depends on the need and the premise. Next question asked by Haranetha Harish asks when site constraints limit our pipe slopes, what is the limit state gradient for our drainage veins to ensure gravity flow? It stays efficient in a small scale residence.
Okay. Better to refer code book. It specify very clearly. For a rule of thumb, I am giving 2, 3, this one. Inside the toilet, generally it is said in a code, 1:60 is the slope for a quicker disposal of sewage into the vertical shaft. When it reaches the vertical shaft and coming onto the horizontal, maybe in the basement ceiling or on the ground area, the slope depends upon diameter of the pipe, where 100 diameter of the pipe, the slope is 1:100. I'm giving a rule of thumb, otherwise better to refer the code. 150 dia is 1:150. 200 dia is 1:200. It may be 180 or 190, but these are the things which are clearly defined in the code. Sharat sir has come. You will
Oh,
take
I'm sorry.
your
I'm
two
sorry for
questions.
the glitch. I got
Yeah, yeah, no
No
issue,
problem,
no
sir.
issue.
Prasanna
disconnected
sir
on
was
the.
kind enough to take the questions.
Okay.
Yes, sir. The question actually asked how to, when site constraints limit our pipe slopes, how to ensure gravity flow and it stays efficient in a small scale residence. So we
Yeah.
were discussing upon that only. Yes.
Okay. Has the question been answered or?
No, no, it's not answered. You can
Yes, sir.
take a
You're
third question.
Oh, generally, your external diameters, when you talk about, you restrict yourself to 150 mm to 230 mm or 200 mm, depending uh, on what type of pipe you're using. So 150 mm, mostly the slope used is 1:100, anywhere between 1:60 to 1:100, because you need something called that the silt should not be deposited. At least once in a day, you should be able to achieve a flow which will bring the deposited silt back. So 1:100 is the maximum permitted. And for 200 pipe, you can go up to 1:150. But these are for shorter lengths. If it is longer lengths, you need to stick to proper design parameters. Because then otherwise, shorter lengths can be done much more easily.
Understood. Sarika asks which water supply system is more economical and effective, gravity or hydropneumatic systems?
Gravity will be now really a big calculation has to be done as to what is the rateable area in that when you lose space. In gravity, what you lose, the system works wonderful. The system is in equilibrium much better than hydropneumatic because the pressures are manageable very easily. Hydropneumatic, you get better pressures, but at the same time, you are depending on extensively on power to deliver that. While in gravity, you are occupying space. Now, for example, the developer doesn't like to reduce his floors because the heights are restricted, especially in where aviation comes under question. So you would like to utilize every floor. So you wouldn't like this intermediate stage floor, right? Then we have the option of, so the economics decide which has to be taken. Both are
Dep-
approachable.
Depends on many factors.
Many factors.
Understood.
For example, a place like Mumbai, definitely land becomes very, very important. But if you are building a house for yourself or a building for yourself, maybe you will think about long-term cost.
Yes, yes. Okay, so next question is architect Soumya asks, how does a brake tank help in managing pressure fluctuation and preventing backflow in high-rise water supply systems?
See, backflow is more a drainage design for phenomena. In brake tanks, you are breaking the pressure zones of the building. That is when I showed the 20 floors, or Prasanna just showed another sketch in which maybe they have also done 15 floors. So you have broken it into stages of 15 floor buildings and you're treating it independently and bringing those pipes in. While if you don't use those brake tanks, as I said, the entire 60 floor building would be about 200 to 225-meter height. Everything would come onto the stresses will come onto your pipe. So you can imagine imagine the loss of energy. Although you may put a lot of pressure using walls in the line, but always remember, more the walls, more the mechanical systems, more chances of failures. So it's always better to keep it as simple as possible for systems to work.
Right. Understood. Okay, so how can a smart water metering system be designed to effectively detect water leakage in residential and commercial buildings? And how the leakage risk can be minimized?
See, generally, uh, no, leakage can be. I'll take the first part of the question. You need to plan much ahead. It is just cannot be an afterthought of putting a water meter. Now, if you take a house with 3 toilets, which is an ideal house, I would say, or 2 toilets or 3 toilets, running, providing water meters to each and every toilet, 3 toilets into the building with 300 becomes cost expensive. It occupies space. While the same thing, I'm just saying one thought. There are many other ways the architect can easily find it out. When you are in the corridor of the building of a particular floor, you run a pipe network. Of course, you need a false ceiling, otherwise it will look ugly. And you enter into individual apartments and you work out the piping so that, of course, all this have to be concealed. But the good part of it is today for high-rise buildings, you are entering into the space because of sprinklers. You need to provide sprinklers everywhere. So you are following a particular route. You can follow the same route and enter into your toilets. This is just one example I'm saying. It's not as easily said like done as I said, but it needs careful planning, careful location of the toilets to sort of fine tune it as one. But there will be tremendous saving, and leaks is moment you realize that you are paying more money because the water is leaking. That is from your consumption, you will come to know. You will be alerted. Just like what happens when you get a fatter electrical bill. You immediately call your electrician to check your points to find out where exactly is the cause. That is one of the major. If you don't measure, you cannot manage. Whatever is measured, you can conserve.
Got it. So one last question I think we can take as the time permits us. What problem may arise in a single stack system if it's not properly designed, and how can we improve it effectively?
Single stack design single stack system, especially when you are going for buildings more than 12, 13 floors or 10 floors or 13 floors, you can make a distinction. It needs to be designed by a proper consultant. The fittings which are to be used, the way the connections have to be done from each branch, there is a particular way the NBC has given proper distances to be maintained. All this need to be put in a design, should be translated into a drawing, and then it should go on site. Because the plumber, poor guy, would not know, and he would connect it depending how easy for him is the connection. So once a drawing is made through proper design, things will fall in place and it works very well. That is where, this solvent system which I was talking about helps you in a way because the solvent has got those connections which which automatically segregates the distances.
Understood. Thank you so much, sir, for taking all these questions so patiently and answering elaborately.
Welcome.
Let's all take a group picture on the successful completion of first session of our first half of our session. So let's all take a virtual group picture. Smile for the camera. Thank you. Over to you, Shrutika ma'am.
Thank you, Ayushi, for this detailed question and answer sessions. Let's take a lunch break now. We will resume by 2:15, and to our speakers, Riverside, please, to our speakers, feel free to step away, refresh, and return. The Riverside link will remain active. And to our viewers on YouTube, the stream will continue with the holding screen. Please do stay connected. Our post-lunch sessions are equally rich and not to be missed. So we look forward to seeing everyone back by 2:15 sharp.
Thank you.
Thanks all. See
Thank
you.
you.
See you
Thank
at
you. Thank you.
Thank you.
open my this one. Speaker, I'll share. 1 minute. I'll share the presentation. You're able to hear me?
Yes, you're audible, sir.
Hello?
Yes, you are audible, sir.
Hello?
Hello, yes, sir. You are audible,
You're
sir.
able to hear me?
Yes, sir. Am I audible, sir?
Yeah, audible, audible. Just I
Yes,
want to
yes.
just check my presentation. I want to share. Actually, it should be in window or this one, madam?
Yes, sir. It should be on window.
Window, no?
Yes, sir.
It's not there.
So now you have to open your presentation slide.
Oh, I have to do the presentation slide, right?
Yes, yes, sir.
It's not coming. Now the share when I say screen and presentation is coming. Okay.
So you have to click on the screen, sir.
Okay. I'll click on the screen.
Then you have to click on window.
Window. Ah, yes. It
Yes,
is there
and
now.
there you can click on the
Just
presentation, sir.
see. It is coming, right? It
Uh,
has come.
no, not yet,
Yeah,
sir.
yeah, come. Yeah, it has
Yes,
come.
it's coming, sir.
It has come now.
Yeah, yeah,
Yes,
yeah.
sir.
Okay, Minesh. Okay, no. Fine.
Yeah, it is
Okay.
coming. You just do
Yes,
the,
it's
you have
okay.
to do the full screen. That's it.
Ah, full screen. It should be like
Slide
this,
slow.
correct? No. Fine.
Yeah,
No.
slide slow.
Yes,
Yeah.
Yes,
yes.
yes, yes. It should be.
Okay. Okay. Okay.
Uh,
I'll just close this now. I'll fold it and keep it, right, or stop sharing.
Yeah.
yes, yes.
You just stop the
Keep it, sir,
sharing.
right now.
I'll stop sharing. Yes.
Yes.
Okay.
Ma'am,
Just check.
can we start, ma'am?
Yes, we
Never
should.
must come.
It's on time.
Okay.
Ayushi may present the screen.
I am presenting, ma'am.
Wait, I'll do that. Okay. Make it clear.
Is it visible, ma'am?
No. You want me to do, Shruti? I'm doing that.
Yes, ma'am. Oh, ma'am. Yes, ma'am.
Is it visible?
Yeah, visible.
Yes, ma'am. It is visible.
Yes. Please begin.
So let's start with the second half session. Welcome back to everyone. Those rejoining the YouTube.
Shrutika ji,
Please continue
can you
the joining
Shrutika
our.
ji,
Yes, sir.
can you make it a full screen?
I'll just try.
Yes, 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 sir. Ma'am, we have to click on the presentation. Okay?
Is it okay now?
It's not coming on
Just
the full screen, ma'am.
just tap the first button after the audio, that Zoom thing at the
It's
extreme
not
left.
going on full screen.
Just tap that icon after that Zoom thing on the at the bottom. Still go down on the left, on the right. The first icon after minus signature.
Is it okay now?
Yeah.
Okay, let's
Yes,
start with
Shruti,
the.
you may begin.
Yes, ma'am. Our third session turns our attention outwards to the larger environmental canvas in which our building exists. So, the name is the exterior and the integration. In a
Madam,
world of.
madam, the screen is showing something else. Yeah, yeah, now that's better.
So, so, in a world of intensifying climate changes, designing for water resilience is no longer optional. From stormwater management and flood resilient design to rainwater harvesting and groundwater recharge, the modern architect must think well beyond the building envelope. And yet, the greatest challenges often lies in the integration. That critical coordination between architecture and plumbing, service shafts, STP locations, sunken or suspended toilet layouts, universal design, these decisions made or missed at the right time define whether a building is harmonious or conflict ridden on site. To guide us through this essential territory, it is my honor to introduce Sri Minesh Sash, sir, mm, a respected expert in integrated plumbing and building services, celebrated for his practical case study driven approach to sustainable water management and design coordination. We are glad to have him joining us on Riverside, sir. Minesh, sir, over to you. Welcome, sir.
You need to stop the screen sharing.
Yes, sir. You can override it, sir.
Yeah. Good afternoon, all. Hope the screen is visible now.
Yes, it is visible, sir.
Yes. Hope everyone had a very good lunch in between the fantastic two sessions. We started with the foundations and the fixtures by Mr. Prasanna, and then the arteries and the veins, wherein Mr. Rao compared it with the arteries and veins of the human body. Now, moving on to the session which I am going to handle is the exterior and the integration under integrated water and sanitation, the blueprint for sustainable architecture. So let's move on with the presentation. Cities today face two opposing challenges: flooding during the monsoon, water scarcity during summer. The reason is simple: we do not manage rainwater well. The greatest design challenge cities face today is not buildings, it is water. How we design for water will define the resilience of our cities in next 50 years. What used to be a 100-year rainfall events are now happening every year, or I would say every few years. Across the world, cities are facing a new water reality. Rainfall patterns are changing faster than our infrastructure can adapt. Storms today are delivering in 30 minutes what used to fail in 3 hours. Drainage systems that were designed decades ago simply cannot cope with these intensities. And when city infrastructure fails, the first place where the impact is felt is the building. Examples like flooded basements, submerged parking areas, electrical system failures, damage to public infrastructure. Now, this is why the stormwater management is no longer just an engineering problem. It is increasingly an architectural design responsibility. Every roof, road, parking lot, and paved plaza prevents water from infiltrating the ground. Cities do not flood because of rain. Cities flood because of how we design them. So the real question we need to ask is not how quickly we can drain rainwater, but how intelligently we can design buildings and sites to manage it. Cities today face a strange paradox. When it rains heavily, we experience flooding, but a few months later, we face water shortages. This is not because of lack of rainfall. It is because we have designed our cities to remove rainwater as quickly as possible. Rain falls on cloud, roads, pavements. Instead of soaking into the ground, it is immediately drained into the stormwater systems and discharged into the rivers or the sea. So what should be a valuable freshwater resource becomes a lost opportunity. The challenge today is to transform rain to drain to lost resource into rain to capture, to reuse, and recharge. Let me ask 3 questions to everyone present today in this session. The first, when do we freeze the stormwater strategy? Is it decided during the concept design or after the services engineer comes into the project later on? Is water management considered before the basement planning is finalized? Because the basement depths, ramp design, sump locations, and drainage slopes all depend on it. And the third question, does the drainage drive landscape designers, or does landscape happen first and drainage is adjusted afterwards? These decisions determine whether stormwater becomes a design asset or a construction problem. The success of stormwater management shall never be decided on site. It shall be decided at the design table. Stormwater is not waste. It is a seasonal fresh water that demands architectural consideration from day one. For decades, stormwater design followed a very simple philosophy. Collect the water as quickly as possible, moving it through pipe or channel networks, and discharge it into the nearest lakes or river or sea. This approach worked reasonably well when cities had more open land, lower densities, and moderate rainfall. But cities today are very different. Rainfall intensity has increased significantly due to climate change. Urban surfaces like roofs, roads, parking areas prevent natural infiltration. Stormwater pipes have fixed capacities, so when rainfall reaches that capacity, flooding occurs. So the problem is not that we received too much rain. The problem is that we designed our cities to remove water quickly instead of managing it intelligently. And this is why the future of urban design is not about faster drainage, it is about smarter water management. As I said in the last slide, for more than a century, the philosophy of stormwater design was very simple. Collect the water as quickly as possible, move it through pipes, and discharge it into the nearest river or sea, correct? But today, we recognize that rainwater is not a waste product. It is a valuable freshwater resource. So the modern stormwater design shall focus on 5 key actions. Capture rainwater where it falls, on roofs, landscape, and open spaces. Delay, that is, slow down the runoff to prevent the sudden flooding. Store water temporarily in tanks, ponds, or underground reservoirs. Reuse it for irrigation, flushing, and cooling. Recharge the excess water to infiltrate into the ground and replenish the aquifers. So the goal is no longer to remove water quickly, the goal is to manage water intelligently. And the biggest obstacle to this approach in cities is something we all have created ourselves. Hope you all agree with me on this. Any guesses? It's the impervious surfaces. The single biggest reason cities flood today is something very simple because of the impervious surfaces what we have created. When the rain falls on the natural land and large portion infiltrates into the soil, some water evaporates, some flows slowly to the stream, and a large amount recharges the groundwater. But when we urbanize land, we replace soil with roofs, asphalt, concrete, and pavements. These surfaces prevent water from infiltrating. Instead of soaking into the ground, rainwater immediately becomes a surface runoff. Studies have shown that the urban areas generate 2 to 6 times more runoff than the natural landscapes. So the more we pave our cities, the more water we push into the storm drains. And when those drains reach their capacity, flooding occurs. So the question is not how we drain water faster, but how we bring back infiltration into our urban design. When we talk about stormwater, most people immediately think of engineers and drainage pipes. But in reality, the behavior of rainwater is determined much earlier at the architectural design stage. I can explain on this. Architects decide the roof geometry. They decide the site grading. Architects are the one who decides the landscape layouts. They decide how much site is to be paved. So all these decisions determine whether the rainwater infiltrates into the ground or becomes runoff that floods our city. In other words, architects are not just designing buildings, they are designing the journey of water through the site. And if we begin to design with water in mind, buildings can shift from being part of the flooding problem to becoming part of the solution. If impervious surfaces increase runoff, the next question becomes how should buildings respond to this reality? The answer is flood resilient design. The flood resilient buildings are designed not just to keep water out, but to manage water intelligently around the site. The strategy can be like one of the simplest strategies, like raising the plinth level so that the building remains above the potential flood levels. That is what we call elevated plinths. The site must be graded so that the water flows away from the building rather than towards it. That is, if we design for controlled drainage. Stormwater should have a clear path to drainage systems without accumulating near entrances or basements. That is, we plan for safe discharge. Basement ramps must include trend drains and some systems to prevent the flooding and in a way protect the basements. So this is how the rainwater concepts has to be planned. Flood resilience is not achieved by bigger drains alone. It is achieved by designing the building and the site to work with water rather than against it. In any building, the roof is the first surface that receives the rainwater. And in most cases, it is also the largest catchment area. The way we design the roofs, its slopes, drainage points, overflow systems, and all determines how safely this water is managed. Proper roof slopes guide water towards drain and prevent ponding. Drain spacing, locations of drain, and the pipe capacities must be designed to handle peak rainfall intensity. Emergency overflow provisions are critical to prevent water accumulation and structural damage. So the roof is not just an architectural surface, it is the starting point of the building's stormwater system. Here I like to explain on conventional and siphoning roof drainage. Since the roof is the largest catchment area, the way we drain, as I said, the way we drain our water becomes very critical. Now, gravity drain is the conventional system, as I said. Traditional roof drainage systems rely on the gravity flow only. The pipes are only partially filled during this case with water and therefore must be installed with a continuous slopes. This requires larger size pipes and multiple downtake pipes, which often create coordination challenges within the buildings. On the other hand, when we talk about siphonic systems work differently. They are designed so that the pipe runs completely full, creating a siphonic action that pulls water rapidly from the roof. Here I'll like to highlight one thing, that everyone in our younger ages, each and everyone who is present today in this session, they might have experienced the siphonic action on their own. Just imagine as a kid or as a youngster, when we were driving scooters or two-wheelers and there was no petrol, we used to use a small pipe, a small tube, and suck water from the petrol tank of a scooter and fill the bottles or transfer to the other vehicle. Now, this is what a siphonic principle works on. So, in case, as you see from the images in the sketch, the left one is a conventional, traditional gravity system, wherein you can have multiple downtake pipes, whereas in the siphonic system, you can have one pipe or a couple of pipes, and the entire drain can be handled. However, siphonic systems are particularly effective for large roof spans such as malls, airports, and industrial buildings, since it can significantly simplify the roof drainage system. I talked about the emergency roof overflow. I mean, this is not a very common practice in our country, but this is very important and is accepted by a lot of international codes. While designing a roof drainage, we must always assume that something can go wrong. Primary roof drains may get blocked by debris, leaves, or inadequate maintenances. And there are cases wherein water starts overflowing into the house from the terrace entrances. If water accumulates, this creates a significant structural loading also. So just a few centimeters of standing water on a large roof can add several tons of additional load on the building. However, there is a solution to this problem. Many international building codes, as I said, mandate for emergency roof overflows. These are the outlets which are provided on an alternate path for water to discharge when the primary drainage system is overwhelmed. You can see in the image here where the primary roof drain connected to the downpipe, whereas the emergency overflow scupper, which allows water to discharge externally, if you can see this. Importantly, this overflow must discharge in a visible location so that the building managers immediately know that the drainage system is overloaded. Sometimes the emergency roof overflow can also be a critical structural safety mechanism. Basement flooding is one of the most common problems faced in urban buildings. During heavy rainfall, water flowing down the basement ramps can quickly enter parking areas if proper drainage systems are not provided. The main risks are ramp runoff, wherein the basement ramps act as a like channel directing the rainwater straight into the building. When the city drainage systems become overloaded, water can flow back towards drainage pipes, creating sewer backflows. When the site levels and the grading is not planned properly, during heavy rains, the stormwater can enter the basements through ramps and other openings kept for ventilation. I had personally seen some water penetrating through the basement retaining walls and the lift pits into the basement in high water table regions due to poor and improper waterproofing. These problems can be mitigated by solutions like installing a trench drain at the top or bottom of the ramp, which can help intercept the runoff before it enters the basement. The collected rainwater from this trench drains is then directed into the sump pits and pumped safely to the external stormwater discharge points. Backflow prevention valves can be used to stop the water reversing into the building when municipal drains are overloaded or overflowed. Proper waterproofing is, as per the experts' advice, shall be applied to the exterior of the retaining walls as well as below the foundation rafts, which will create an impermeable shield against the moisture. This is very much mandatory in all the areas with very high water table. Basement flood protection is not just about pumps. It begins with good and logical planning of ramps, slopes, and drainage points. Another important point is the subsoil drainage for the basements. While we often focus on the rainwater entering the basements through the ramps or surface runoffs, we often ignore the subsoil drainages, specifically in high water table areas. This water exerts hydrostatic pressure on the basement walls and the floor slabs. Over the time, the pressure can cause seepages through joints, cracks, and construction interfaces, which can be dampness, leakage, mold growth, and even structural deterioration. In fact, if this is not taken care of, this subsoil water can even topple the roof slab in the basement and flood the basements. So the solution is to design subsoil drainage systems to intercept this groundwater before it reaches the basement structure. The system components mainly required are the perforated pipes are placed around and below the building foundation to collect the groundwater. These pipes are then covered with geotextile membrane. Then these pipes are covered by a graded gravel layer, which allows water to move freely towards this pipe and not allowing mud, soil, or any other debris to block the perforations. You can just see the section over here on the screen images. It will be very clear. Drain membranes or the boards can be installed on the basement walls to create a path on the exterior of the basement walls to create a path for water to flow down. All this collected water is then directed into the sump pit, which is constructed below the lowest point of these perforated drains, and is pumped out safely from the building. Please note that subsoil drainage does not stop groundwater. It simply provides a controlled path from the water to move safely away from the structure. This, in a way, will also help the structure consultant to design these foundations, since this can reduce the uplift pressure on the basement roofs. Now, after the building, let us move on to the landscape and the external stormwater infrastructure. Modern stormwater design increasingly integrates the drainage systems with the landscape designs. Instead of directing all the rainwater immediately into the underground pipes, landscapes can help manage water naturally. These systems slow, store, filter, and infiltrate stormwater within the site. When the landscape design and the stormwater management work together, open spaces become active infrastructure rather than the decorative elements. This approach not only reduces the flooding risk, but also improves urban ecology and public spaces. Rain gardens are the shallow vegetated depressions that collect runoff from roofs and paved surfaces and allow water to infiltrate slowly. This is a typical section of a rain garden. Now here you can see a typical section of a bioswale. These are the landscape channels that convey stormwater while filtering sediments and the pollutants. And these are the permeable surfaces, a typical section of a permeable surface, which allows the rainwater to infiltrate through the surface into the gravel layer below, reducing the runoffs. I mean, landscape architects and architects and landscape consultants are very well versed off with these rain gardens, bioswales, and permeable surfaces. The only thing is, these things have to be conceptualized at the initial stage of the project. In addition to the landscape infiltration systems, cities often use the stormwater storage systems to manage the large rainfall events. Detention systems temporarily store stormwater during the heavy rainfall and releases it slowly into the downstream drainage system. Their primary objective is to reduce peak runoff and prevent flooding. Retention systems, on the other hand, store water for longer periods. These systems allow water to infiltrate into the ground or be reused for irrigation and landscape purposes. So while detention focuses on flood control, retention systems contribute to both flood management and water conservation. So with all these previous slides, can we say that effective stormwater management requires a comprehensive multi-layered approach? By strategically combining various green infrastructure elements, we create resilient systems that mimic natural hydrological processes, managing water where it falls and protecting our communities and ecosystems. This holistic strategy drastically reduces urban flooding, minimizes pollution entering natural waterways, enhances groundwater reserves, and creates healthier, more sustainable urban environments. Each component plays a very vital role in slowing, cleaning, and managing stormwater effectively. So now, once the stormwater is captured and stored, the next opportunity is to use this water productively through the rainwater harvesting systems. One of the most effective ways to improve water sustainability in building is through rainwater harvesting. Rainwater harvesting systems capture rainfall directly from the roof surfaces and store it for future use. The roofs act as the catchment area where rainwater is collected. Gutters and downpipes convey this water from roof to the harvesting systems. First plus is a device or a mechanism which diverts the initial rainfall or the first rains, which may contain dust, debris, and contaminants accumulated on the catchment surfaces, preventing them from entering the rainwater harvesting systems. Before storage, the water passes through the filtration units that remove debris and suspended particles. And the final filtered rainwater is then stored in tanks and can be reused for non-potable applications or directed to the groundwater recharge. Rainwater harvesting transforms building from waste consumers into waste collectors. Let us have a look at a simple example to understand the scale of the rainwater harvesting potential in a normal simple building. If we assume a small building of 1,000 square meters which can be any normal residential or a commercial building, if the annual rainfall is around 1,000 millimeters or so 1 meter, and if I consider 0.9 as the coefficient of runoff, considering the first flush and the other losses, then 1,000 square meters multiplied by 1 meter multiplied by 0.90 is roughly 900 cubic meters, which is 9 lakh liters per year. This means that if a single building with 1,000 square meter roof area can potentially store 9 lakh liters of water per year, imagine the potential for large projects with huge roof areas. In fact, we can be a significant producer of water rather than just a consumer. While rainwater harvesting helps capturing rainwater or capturing the rainfall, the larger goal is to restore the natural water cycles. Groundwater remains one of the most important sources of water supplies for the cities. And groundwaters are already depleting across India and across many parts in the world. However, rapid urbanization has replaced the natural source surfaces with concrete and asphalt, drastically reducing the groundwater recharge. So at the same time, excessive extraction of groundwater has led to declining water tables in many regions. Groundwater recharge systems allow rainwater to infiltrate back into the ground and replenish the underground aquifers. There are various methods for the same, like recharge pits, which allow the filtered rainwater to percolate slowly into the surrounding soil. The recharge trenches, they work similarly but are designed as linear systems to intercept runoff over the larger areas. Recharge wells can convey the filtered rainwater directly into the deeper aquifers, and with a reverse borewell or a tube well being constructed within the recharge well, it can take water deep down into the aquifers, directly into the aquifers. The percolation basins are the ones, they are the shallow basins which temporarily store rainwater and allow it to infiltrate naturally. So the groundwater recharge restores the natural balance between the rainfall, surface runoff, and the underground water storage. Thus, we can say that recharge systems transform rainwater from runoff into a long-term water resource. This is a typical section of a in-situ recharge pit, or a factory-made recharge pits are also available nowadays. There are a number of other equipments, some rainy filters are also available in the market. So a designer and the architect, consultant and the architect can coordinate and they can select appropriate system at the initial stage of the design. Let us pause for a moment and reflect on what we have discussed so far. Rainwater falling on our building is not a problem. The problem is how we choose to deal with it. For decades, our approach was simple: drain water away as quickly as possible. But today, we know that rainwater can be captured, stored, reused, and returned to the ground. Roofs can collect water, landscape can infiltrate water, storage systems can manage peak flows, and recharge systems can restore groundwater. In other words, buildings can move from being part of the water problem to becoming part of water solutions. However, all these solutions depend on one critical factor: the integration between the architecture and the building services. And that is where the real challenge begins. We have just seen many strategies for managing the stormwater, rainwater harvesting, landscape systems, recharge methods, as well as in first two sessions, details on fixtures, water supply, and drainage. All these systems are technically feasible, but who ensures that architecture, structure, plumbing, drainage, and the landscape actually work together in a project? Developer, right? How many of you are thinking about this answer? All those who thought about developer are wrong. Unfortunately, we cannot interact directly. I would say it's the architect, because the architect is the only professional who sees the building as a whole. And this is where the real challenge begins: the integration of the entire plumbing systems within the design process. One of the biggest challenges in building design is coordination between disciplines. Architects focus on spatial planning and aesthetics, while the plumbing consultants focus on water supply, drainage, and infrastructure. However, for systems like stormwater management, rainwater harvesting, groundwater recharge, water supply systems, drainage networks, fixture selections, and all, these disciplines cannot work independently or in isolation. For example, a rainwater tank requires space. Recharge pits require proper site planning, proper site gradation. Drainage shafts must align with the toilet layouts. Plumbing systems to be aligned with the fixtures and the fittings selected. Clients, the end users, will have a particular choice of a fixture or a fitting or a shower or a diverter, and the architects and the consultants have to adjust the systems to suit their selections. And there are many such issues which come up during a design process. Now, if these aspects are not discussed early in the design, they become problems during construction. That is why the architects and the plumbing consultants must work together from the very beginning. And so it is very apt to say that architect and plumbing are the two sides of the same coin for any building design. Basically, coordination is not about solving problems later. It is about preventing them during the design. So as said, coordination between disciplines is essential in the building design. However, in many projects, the integration of the services happens too late. Architectural planning is completed first. Then comes the structural engineer who finalizes grid and the column locations. And then it has been given to the service engineers and asked them to fit the plumbing and drainage systems into the building. Now at this stage, shafts may not align, the tank spaces may not exist, and the drainage routes may become unnecessarily complicated. So I would say the problem is not the lack of technology. The problem is the timing of integration. I would very strongly, I would like to make one statement here that integration delayed is integration denied. Now, when the integration happens too late, these are the kinds of problems we see on the real sites. Misaligned shafts, wherein service shafts may not align across floors, forcing complicated piping routing. Drainage pipes become longer than necessary because they have to navigate through structural elements or around the structural elements, since not considered at the initial stages. Sometimes the sewage treatment plants or the tanks or the pump rooms are located far from the sources because space was not planned earlier. And basement flooding, as I said, often occurs when ramp drainage is not considered during the architectural planning. None of these problems are technical. They are all coordination problems. Plumbing problems in building rarely start on the site. They start on the drawing board. One of the most common challenges in building design is the conflict between architectural planning and the plumbing systems. For example, service shafts may not be large enough to accommodate the required plumbing and drainage pipes, as rightly highlighted by Mr. Rao in his presentation. Drainage pipes require slopes, but architectural ceiling heights may not allow sufficient space. Pipes may clash with the structural beams or columns or other services when coordination happens late. And there can be many more such conflicts. These issues are not unusual. They occur frequently when services are introduced after architectural design is finalized. To avoid such things, it is important to start the plumbing design right from the initial architectural concept stage, along with the planning of the structural framing plans. Coordination between architect, structure, and plumbing at this initial stage is very important. All the levels and sections shall be finalized at the initial stage, along with the site bearing levels. Whenever required, depending on the complexity of the project, softwares like BIM, Revit can be used and conflicts can be resolved. All important services block like water tanks, pump rooms, STPs, and other MEP big blocks like transformers, cooling towers, chillers, if they are a part of the design, shall be finalized and coordinated at this initial design concept stage. Remember, water flows by gravity, and gravity does not negotiate with architecture. When planning water storage tanks in building, proper spatial planning is extremely important for efficient system operation. First, the pump should be ideally operated under the positive section, which means the pump room floor should be located below the bottom level of the water tank. Negative section conditions should be avoided because they reduce the pump efficiency and increase maintenance issues. Water tanks are usually planned either within the basements or sometimes within site margins if the regulations permit. Architects and consultants can often use the unused basement spaces or the negative spaces to accommodate the water tanks and pump rooms efficiently. For all practical operations and maintenance issues, the depth of the water tanks are generally recommended to be limited around 4.5 meters, while the pump room should be ideally having a minimum height of 3 meters. The manholes from the tank can be either the top entry or the side entry manholes, depending on the accessibility and the project constraints. In most projects, the pump room also accommodates the water treatment equipment as well as the fire pumps, so adequate space must be allocated during the planning. In most developments, the sewage treatment plants are typically located at the lowest point of the project so that the sewage can flow to the plant by gravity. They are also ideally located towards the side where treated water will be discharged or connected to the municipal sewer systems. In many projects, STPs are planned within the basements or occasionally in the side margins, depending on local regulations. Architects and consultants can effectively utilize unused basement spaces or the negative spaces for locating the STP. And for all operational efficiencies, STPs require a significant vertical clearance. Typically, about 5 to 6 meters of height is required to accommodate tanks, blowers, piping, and maintenance access for a proper planning without any compromise. However, this can vary a bit depending on the final STP technology selected, location of STP, and the type of the project. In terms of area planning, a simple rule of thumb is that the plant area roughly corresponds to the treatment capacity. For example, a 200 cubic meter per day STP would require approximately 200 square meters of space Again, this can vary depending on the STP technology, but this figure can be kept in mind during the initial planning, architectural planning, to ensure that the spaces are earmarked for particular services. Proper ventilation is critical because STPs generate gases and odors, so dedicated exhaust shafts and ventilation systems must be planned. And finally, an adequate access must be provided for the maintenance activities such as the sludge removal, equipment services, and replacements. Now we talk about bathroom planning. Some points were already discussed in the earlier sessions, but I'll cover in brief the major things which are required. A bathroom planning will consider a shaft sizing, either it's a sunken or a suspended drainage. The wet areas is explained, it was already explained by Mr. Prasanna. The slopes, requirements of the ledge wall, selection of the sanitary waste, the pipe material selection, and the tile selection. When we first look about the plumbing shafts, Rao Sahib, in Mr. Sarath Rao's presentation, he laid emphasis on sizing the shafts properly. Now here I have listed few services in the slide. I mean, all these or any of these are to be accommodated in the shafts depending upon the project requirement. As such, there is no fixed codal rule for the shaft size. But the shafts must be accommodate all the services and safety and maintenance access also. In many projects, the shafts becomes undersized because they are planned after architecture and structural coordination. I would say properly planned shaft should always include space for pipes, valves, access doors, and the maintenance platforms. Few more services like water heaters, flush tanks, HVAC pipes, or artificial ventilation, lighting are also a part of the shafts depending upon the type of the project. Now, looking to all these different services, say for example, when we were talking about water supply in the first session, Prasanna was explained about a high-rise building. So when in a high-rise building, a zoning is required. So when we talk of a zoning, you need to have multiple downtake pipes. So all these multiple downtake pipes are to be accommodated in the plumbing shafts. If the hot water system is central, then again the shafts has to be designed for your central hot water supply pipes as well as for the return pipes. So shaft sizes becomes very much important at the initial stage of the project. Now again, most important and the debatable question: bathroom planning with a sunken slab or a suspended drainage. I mean, there are many differences of opinion among the architects and the designers as well as the developers. And I would not like to get into that deliberations or debate, but according from a consultant's point of view or a person in this industry, plumbing industry point of view, I would like to highlight some benefits of a suspended drainage. The suspended drainage reduces the dead weight. All pipes are suspended at the ceiling level or the soffit of the ceiling level at the below slab. In this case, you can provide a 50 to 75 mm of a sunken slab, which can account for drop, slope, and the waterproofing. In case of a suspended drainage, the maintenance is very easy because breaking any false ceiling is very easy as compared to breaking the entire sunken toilet floor with expensive finishes. The maintenance and the repairs works can be done in a day in case of a suspended ceiling, whereas if it's a sunken slab, it can take maybe 10 days or maybe 2 weeks or maybe 3 weeks, depending upon the scale of the toilet, because you need to redo everything right from the scratch. Here are some drawings. I mean, a same toilet, how it can be designed, like this figure on the left shows the drawing with a drainage through a sunken floor, whereas on the right, the drawing shows the suspended drainage, wherein the pipes are suspended at the soffit of the slab at the below level. Now coming to a $1 million question, what depth of sunk is required? A minimum of 50 mm water seal is very much essential, and so one needs to use either a P-trap or a deep seal trap. Now, looking to the sizes available in the market of these P-traps or the deep seal traps with 50 mm water seal, a recommended sunken depth is minimum 300 mm. Again, there is no codal provisions or codal compliances with the sunk depth required. It is all with respect to the equipment we are planning. Say, for example, if we are designing a multiplex, a theater, or a hospital with a huge battery of fixtures, and it's a large toilet, maybe a 300 mm sunken toilet will not be possible for that huge toilet. Maybe you will need to design for a 450 mm sunk or a 600 mm sunk if you are going ahead with a sunken design. If it is a suspended design, then the sunk can be 30, 50 mm or 75 mm just for the sake of waterproofing. Here are some images, actual images of a ceiling hun plumbing, wherein you can see the pipes are suspended in the ceiling. Proper core cutting can be done at a later stage, or maybe sleeves are kept at the design stage with proper coordination. Another most important point which was discussed earlier was, and highlighted Mr. Rao, was the shaft access. So minimum width of shaft access required is 600 mm and the height of the access is required around 900 to 1200 mm. A working platform should also be provided in the shaft, because when you are working on a high-rise towers, just see these images. These are on the image on the right shows a working platform, a properly planned shaft wherein a cutout is kept for the vertical pipes and a shaft is provided. Whereas on the right you can see a plumbing shaft with no service platform. Just imagine a high-rise building of say 20 floors or 30 floors, or maybe nowadays people are going up to 150, 200 meters. And if a service platform is not provided, how is a plumber going to maintain or repair the shaft? So a service platform becomes a very much important necessity. These are some few more images of planned shafts, which shows that how important it is to plan a shaft right from the day one. Toilet slopes. When we are going ahead with a point drain, the slopes as shown in the red arrow are very much required. But when you are going for a shower drain or a shower trench, the slopes as shown in the reduction are to be provided. Just so I think my presentation is not moving. Just a sec. Yeah. So the most important is how you design your bathrooms, how you design your shafts, how you design the access to the shafts. This all matters very much at the initial stage of the design. Once these designs are frozen, then life becomes very easy for the project. One more important constraint which we always face, all the architects face and the plumbing consultants face, is the requirement of the ledge wall. If you see an image at the top, this section at the top, the beam is overlapping with the bathroom wall, whereas in the lower section, the beam is offsetting out into the bathroom. So what happens? See, in the upper bathroom, in the upper section, I just need a 100 mm or 150 mm ledge wall to route my drainage pipes. Now, even if I have to route it into the basement, into the sunk, or maybe into the below the soffit, the ledge wall will be required. And when you look at the lower image, because of the offset of the beam, I need to provide a ledge wall which might be 200 mm or maybe 230 mm wide, depending upon the offset of the structural beam. And this makes your toilet width reduced. So even if you are planning even if a toilet is planned for 1.5 meters wide width, because of this 230 ledge wall, your width of the toilet can be reduced. So again, this integration with the structure architect and the plumbing consultant at the initial stage is very key in designing the bathrooms. These are some standard measurements of a toilet planning. I mean, I don't have to talk much about this because you guys are you are much more masters in this designing. Water flows by gravity. And as I said earlier, gravity does not negotiate with architecture. Water systems in building do not fail because of technology. They fail because of design decisions. And those decisions happen at the initial stage of any project. Plumbing engineers can optimize the system. But if space levels, structure, and shafts are not planned properly, no engineering solution can fully fix the problem. So now in the second part of the presentation, we focus on the integration of the challenge. So many water-related problems in buildings are not due to the lack of technology. They occur because plumbing systems are not often considered after the architecture is already finalized. Drainage systems depend on gravity. Tank requires space. STPs require location and ventilation. Shaft must align through the building. Now, if these elements are not planned properly or not planned at the early stages, engineers are forced to compromise during the construction. So good buildings are not just the result of a good design, they are the result of a good coordination. Now here's a small architect's water design checklist. I mean, before freezing the design of any project, some critical questions should be asked. For stormwater and the site infrastructure, I would say, like, first, let us ensure that the site drainage strategy, rainwater harvesting, and recharge systems are already integrated into the design. For water infrastructure, let us ensure that major water infrastructures like tanks, pump rooms, and STPs are properly located and have adequate space and access. And from service level integration, let us check that plumbing systems are properly integrated with architects, including the shafts, slopes, and bathroom planning. If these aspects are addressed early, most integration problems in projects can be avoided. Throughout this discussion, we have looked at the stormwater resilience, rainwater harvesting, groundwater recharge, and the integration challenges between the architecture and the plumbing. Water will always flow through our buildings. Our responsibility as designers is to ensure that this journey is safe, efficient, and sustainable. Because the future of our cities will depend on how well we design with water. Every building receives water from nature. What we do with that water determines the resilience of our cities. If we capture rain, reuse treated water, and recharge groundwater, buildings can become part of the natural water cycle. That is what designing with water truly means. Thanks. Thanks a lot.
Thank you, sir. Thank you, Manish sir, for those highly practical and eye-opening insights. As the case study shows so vividly, harmony between structure and services must be planned, not hoped for. So now moving on to the question and answer sessions. My co-host Ayushi will take over from here. Over to you, Ayushi.
Thank you so much, Shah, for detailed presentation and directing us all on a path to integrate planning, design, and plumbing architecture and make our buildings a part of natural water cycle. So, moving on to the questions, uh, participants would like you to shed some light on the maintenance aspects of water harvesting system.
I didn't hear you. There is no disturbance.
So, can you hear me now?
Yeah, there is huge disturbance coming here.
Apologies, sir. Can you shed some light on maintenance aspects of the water harvesting system?
Can you throw some light on?
Maintenance aspects.
See, maintenance aspects of harvesting systems.
Yes.
Okay.
Yes.
See, harvesting systems, when you plan any harvesting systems, there are two things. One is either you store the water as a part of your harvesting system, or whether you recharge your groundwater tables. So when you are talking about the first, the storage of the rainwater as a part of harvesting, as I said, the first flush mechanisms becomes very important, because that is where you ensure that the debris, leaves, and the mud, soil, whatever is present on the roofs, they are all removed from the system, and then the water is stored. And when we are going to reuse the stored rainwater, the only thing is, when you are using it again, you need to filter that water appropriately and then reuse it, even for non-potable purposes. When I'm looking at the aspect from groundwater recharge, it becomes very important that this surplus water, groundwater recharge can also happen from the open areas, the landscape areas. So there are all the chances of leaves and all that stuff coming into the recharge wells or recharge systems. So a pre-monsoon cleaning of the rainwater harvesting wells, the recharge wells, is very much important in a long life and a maintenance of the systems.
Sir, how do site conditions like soil type and slopes influence the choice of subsoil drainage systems in basement design?
I would see subsoil design, type of the soil plays a very important role in a subsoil drainage. When you are looking at, say, for example, black cotton soil, it will never allow water to penetrate through it. So whatever water is, the superficial water is there in the site, it is always going to remain within that area. Now, as I said in my presentation, subsoil drainage is not meant for controlling groundwater or stopping the groundwater. It provides a safe passage to the subsoil water, to the groundwater, out, and ensure that it is disposed of from our site.
As we were talking about the subsoil, also on roofs, does the surface of a roof give better runoff for water harvesting? I mean, does the material matter?
What?
Which type of roof surfaces give better runoff in water harvesting?
Lot of disturbance are there.
Yeah, there is disturbance back on the background.
Ayushi, share the file with me. I'll ask from here. Just send me on WhatsApp.
Sure.
Mark it which one to begin.
I think she was talking about some surface of roof, right?
So just give us few seconds. Yeah. So we are on third question, Ayushi. Hello.
Yes,
Are we on
also
third
dropped the
question?
question in our chat box. Yes.
So, sir, the question is, which type of roof surface gives better runoff for water harvesting?
Any hard surface in the roof will give a better runoff. It can be a tile or a china mosaic or anything.
Okay. And another question is, how are recharge pits successful in a metropolitan city like Delhi or Kolkata or Mumbai?
Recharge the success of the recharge pit depends very well on the groundwater table. The recharge pits can work very well in, say, places like Rajasthan or Delhi or Ahmedabad. But maybe if we are looking at Mumbai, maybe it can work good in the suburbs of Mumbai as compared to the South Bombay. When we are looking at a recharge pit in, say, Goa, it won't work because of the high water table, because of the vicinity to the sea. So a system which is to be planned, a rainwater system has to be planned, keeping in view the geographical location of the site, of the place, and accordingly the harvesting systems can be designed.
Sure. Another similar question, sir, that how can groundwater be recharged into deeper confined aquifers at 200-meter below ground level in higher ground tables and saline areas of Bengal?
See, I had just spoken about that in my slide, that when you are making the recharge wells you can have a reverse bore in that, and that reverse bore can be taken deep down into the deeper aquifers, say 200 meters or 300 meters as per the below ground aquifer levels. And if I mean there is a systematic, or I would say scientific study which can be done. It's an hydrogeological survey by resistivity method. It can be taken out, and it gives a very good indication as aquifers at which level are able to sustain or can accept more water. I mean, it can also give data on at which level you need to do the bore wells, but it can also help in the other way, right? How you recharge your deeper aquifers.
Okay, thank you, sir. There's one last question that I think we can take. Is it possible to store a huge quantity of water collected during rainy season in a very high rainfall region to be stored for summer months in independent house? I don't know, practically, or how many months we can store such water?
See, storing rainwater is a challenge.
Terms of
Storing a rainwater can be a challenge for a longer duration. But if you are talking about, say, the areas where there is frequent rain, very high, heavy rainfall, and if you want to store that water throughout the year, then it's a simple mathematics. I mean, how much water you are going to consume per day, and accordingly multiplied by the days. Say you remove the 3 months or 90 days of the rainy season, so another 270 days multiplied by the amount of water you use, that capacity of rainwater tanks are to be constructed. That is a very simple math. But the point is, even if you are able to store your rainwater for say 90 days or 100 days and reuse it, it also makes a huge impact because you are saving 30% of your water, fresh water demand.
Yes. Sir, is there any implication on maintenance and cost for this?
See, rainwater systems does have a maintenance of cleaning, pre-cleaning and post-cleaning during after and before the monsoon. That's the only cost, because this is all these are all natural systems what we are looking at. There is no machines involved, and we are simply following the rule of gravity in most of the systems.
Right. I think that's it for the day. We can proceed. Thank you so much,
Thanks a lot.
Manish sir.
Thanks a lot, and
Shrutika,
thanks a lot, and I'll thank the entire COA team and IPA team for giving this opportunity to present in front of this august crowd, and specifically in front of the architects. And I would like to say that we look forward for more detailed training in the month of April when we go ahead with the IAPL, wherein we'll be throwing more light on the technical aspects of this, and many of the questions which I have come up today, even in the first two sessions as well as in this session. Maybe we'll be able to justify those answers in those training sessions when we take up from 6th of April.
Very right, sir. And I mean, I'm also taking this opportunity to again appraise all our participants who might not have been there for the time when we actually announced this. So, as part of our collaboration with the IPA, COA has organized today's event, but this is like a precursor event to a 5-day offline program, which is like a training program for both architectural practicing architects and the academicians, and this will take place in Delhi between 6th to 10th April. And as Minesh Shah sir just said, it's going to be more rigorous, more detailed, and there will be lot of takeaways from there. And soon after today, maybe next 2 days, we will be floating that, and do register for the same. And we look forward to more such opportunities where we can collaborate and are some meaningful knowledge providers to our society and stakeholders. Thank you so much, sir. Over to Shrutika.
Thank you so much, Shah sir, for those highly practical and eye-opening insights. As the case study, okay. So let's move on towards session 4, the blueprint for excellence and the next step.
Last session.
Yeah, this last session, sir. The blueprint for excellence and the next step. The best lesson come not from textbooks, but from reality. Our concluding session brings together everything explored today through a rapid fire review of real world case studies, contrasting common design pitfalls in residential and commercial projects against optimized building solutions. This is also our moment of synthesis where the thread of the day are drawn together into a complete holistic picture of what integrated water and sanitation design truly means for the practical architect. To bring these remarkable day to a meaningful close, it is my honor to introduce Dr. S. Veerappan sir, present chairman IPA chapter Chennai, an eminent authority in plumbing design excellence, whose ability to distill complex real-world challenges into clear, actionable architectural wisdom makes him the perfect guide for the final chapter of our journey today. We are truly honored by his presence on this meeting. Over to you, sir.
Yeah, good evening to everyone. And Rashmi madam, I need some 2 3 people as I already informed you, madam. Just to have an interaction with you all.
Ayushi and Nidhi and Akanksha, I have just spoken to them. I'm just reminding them. They'll join, sir. You may begin.
Okay, I'll just sharing my presentation.
I think we can begin, sir. Akanksha, Ayushi, Shrutika are already here.
No, I'm just connecting, madam.
Okay, sir.
I'm just connecting. Just see whether it is visible. Is it
Yes.
visible, madam?
Yes,
Yes,
sir.
sir, we can see it.
Ah, okay. Good evening to everyone present here. And before I go, I just thank our IPA management and COA for giving this opportunity. And from the morning, you have been going through session 1, 2, 3, all related to plumbing, in the sense water supply and sanitation. You know, water supply and sanitation is nothing but water in and wastewater taken out. And further, rainwater, whatever it's happening, which we are storing nowadays, nobody is allowing out, I mean, to be taken out. With this small intro, my flow of presentation will be like this. Actually, it will be an introduction with an advancement, a message from famous architect, and MEP systems, classification and coordination, case studies, troubleshooting, problem statement, what went wrong, solutions and takeaways with respect to the residential buildings. Few problems on water supply, few problems on sanitation, 1 or 2 problems on stormwater drainage. Whatever the third session, hope Minisha given lot of insight into the coordination related to that actual case study which you are going to see now. In the sense, whatever I'm going to show here, I'm not going to name the site, name the consultant, name the this one, and whatever the real problems what we faced when I was in the previous organization. Even now, I'm just highlighted you only few here, so that architects present in the forum will get benefited. I'm sure they will get benefited in another next 45-50 minutes. Please watch very carefully, and I need some sort of input. Even if you can make a note, you can make a note of it. And the bottom line is no blame game here, like unlike at the site level. Like blame game, when I say, it is a blame game between the consultants like plumbing, electrical, fire, AC, etc., etc. Okay, and few case for an hospital and the sewage treatment plan, and finally attributes and conclusions. Before I start this introduction, I just want to have ice breaking a slide for all of you, just to understand one thing sure for the audience. The statement, which the case study which you are going to present, you will able to realize the whatever the takeaway from the statement. The first, early morning we are all gearing up for what, where we are going, where we will be going during normal day, to office, to college, wherever we go. Suddenly your parent is calling and stating that there is a problem in the wash basin bottle trap, that it is leaking. Something they are telling, your wife is telling you, or your husband is telling you, as a, if you are a wife. What an individual will do immediately? Anybody can tell what an individual can do? I'm just passing here. An individual
Try
person,
to
what he
fix
will
it
do?
yourself, maybe.
Yes, try to fix it. First thing is, you cannot fix. See, anybody can tell that you can fix. No, we'll go and close the angle wall to stop the water temporarily. Correct? Temporarily to stop the water. The next is, you need to call your plumber to arrest that. That is the normal way of doing. Where are we now? My dear architects and the engineers, where are we now? Where are we going? Just see the slide here. Where are we going? We are going in the digital world. App like artificial intelligence. So many things are coming in the present scenario. When this is coming in the present scenario, one thing very clear: physically something has to be done for the better coordination, for better from the better aesthetic point of view. Also, some physical work has to be done, and particularly an engineering field, but civil engineering, architectural, will have to follow certain rules and regulations and certain checklist. See this cute fellow, what is doing? The moment we are telling that bottle trap is leaking, he is opening that laptop and analyzing what is the solution to be given for this. Maybe he wanted to, this cute fellow wanted to give solution to this problem. And interpretation can be in any way. I just, as an what do you call, as an ice breaking, I'm just showing this slide. Why I'm saying here, it is, in my experience, architect has high level of visualization, more rather than the engineers. Engineers have, but high level of visualization. Now during the present scenario, yeah, because I used to take so many classes for the students and all, your imagination power, visualization power has come down. Even thinking power has come down because of this present apps like even Chat GPT. If you want to write a letter, we are all going to Chat GPT and putting it, so that our thinking, our brain is just is coming down. So this is the scenario which is going on, and end of the day, I strongly believe, I think in our Minesha session also told, architect plays a major role. And in fact, to me, if you ask me, they are the king. They are the king, but only thing is some sort of, what do you call, like Mr. Our Sarat sir was telling me, some tolerances, some sort of, what do you call, generosity should be there for my architects. That's it. With this small introduction, and one more thing also I'm telling you, those days you will remember your father phone number, mobile landline number, everything. Now, if you ask your own phone number, even if you ask some college student his own number, he will forget. Even married people will forget his wife number itself. I know what will happen at the end of the day. Okay, so having said that, let me move on to the next slide. That is the quote from the famous architect. This we always do it in our Indian Plumbing Professional League. Okay, and see the message. There was a time when I knew a lot about building services, but today, every time a consultant comes to my office, there is something new as building services have evolved into a science. I think it is a must learning for every architect engineer. And I can assure you that if architects, engineers know more about services and more about structures, they will be able to design buildings better. Are you all agreeing with me? This is the quote from a famous architect, actually. In
Yes,
fact,
yes, yes, sir.
architect
Certainly.
Hafiz sir told about this. So, lot of materials are coming nowadays. I think Mr. Sarad sir, Binesh sir, even our BOPK also told about the materials. I'm not going to touch about the materials, but the point is so many materials are coming, how we are selecting it. But more than my plumbing engineer, architect also should know about these things. That is the message here. And going more to a small, here again, an introspect, that is reflection. Do you all agree that irrespective of the size, scale, category, and location of the project, plumbing, water supply, and sanitation services does not cost more than 6 to 8% of the total construction cost? Point number one. Point number two. Do you all agree that in a handed over project, more than 80-85% of the problems are directly or indirectly a result of the bad installation of plumbing, water supply, and sanitation services due to improper coordination? Do you really feel that we put enough planning, enough resources, best solutions, enough quality control measures to achieve a zero defect installation? If the answer to this is no, then there is a distinct gap in what we feel and what we do. The first tool for zero defect production or zero defect work is training, training, training. The next is the getting into habit of do it right the first time. Again, I'm repeating. The first tool for zero defect production is training. The next is getting into habit of do it right the first time. Particularly any services, we need to do it right the first time. Otherwise, your rework, everything will make your work completely spoiled. So to help you achieve bigger success in the above two important points, associations like us, IPA, Council of Architecture, all committed to the one main objective of training in plumbing, water supply, and sanitation at all levels of architects and engineers. Right, sir? I hope I'm clear to all the audience. I'm clear to all my architects present here.
Yes, sir. Yes.
Yes.
Definitely.
Okay. Yeah. So moving on to the see the one more thing is the objective I told you. Now coming to understand the building components. In fact, Mr. Rao sir has clearly, you know, informed everyone about the importance of arteries and veins. Just see whatever we discuss. No, you connect yourself to the to your own building where you are living, to your own flat where you are living. Okay, then everything we can connect to each other. So this presentation, like others, all the three my colleagues have given, similarly in another 30 minutes you just see, you can connect yourself to all those presentations. I'm trying to connect you to what do you call to your own projects, so that any problem we can you can ask questions at the later stage. Okay, then I'm just coming to the understanding the building components. When I say building components, there are mainly three important components if you take. the civil and structure, and number two, your services, number three, your finishes, architectural finishes. See, the moment, if I see this, the way back, one of a big company, painting company, came to me stating that they want me to be a jury of a selecting the, what do you call, best structure, best, building. And I saw their points. When I was going through the point, it was covering civil, covering structure, covering, and services are not at all covering. That is, points have been given for the civil, finishes, structure, but services there was no points. I told them, why, when you are selecting a best building, you need to focus on all the three, no? Then they understood the game and explained to them, and they went back and came with the some other points. So what I'm trying to convey to all of you is, see, any building, if you are assessing, you should assess on all aspects, because MEP services, particularly plumbing, water supply, and sanitation, is a neglected area. Anybody wanted to see a good building means you should straight away go to the terrace, straight away go to the basement, ducts, and the external features. And even if required commercially, go to the toilet and see how they are finished, how they have taken the lines, how they are, from the operation and maintenance point of view, you ask these questions to them. Then then that when you assess like that, then it is a real assessment. Okay. Having said that, let me move on to the why these three are important. See, a lot of presentations I used to give it to various engineers, architects, and other, big companies. When I the first question, when I put the slide, I'll ask them, which is very very important. If I now ask, architects will come. So I'm putting this one. MEP is important, civil finishes important, architecture important, structure is important. Madam, can you say which is important from your perspective?
All are
Which,
equally important,
which
I
is
think.
important, madam?
Yeah.
Which is important?
All are equally important at different stages, I think.
Yeah, you absolutely correct. But when I take classes for the MEP, people will tell MEP is important. When you take class to the plumbing, plumbing is important. When people finishes, sir, architecture is important, sir. Sir, structure is important, sir. No, 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 no. All the three are important, because your structure is, if you don't have the structure, it will not give you rigidity to the structure. That is important. And coming to the services, as our Sarats have told very clearly, from the functionality point of view, MEP services are important. And coming to the finishes, the way you dress, the way you finish, the way you go ahead with the building, finishes important. Therefore, all three are important. That is, building components are like our human body, and that is why all these are important. And any project you take, I always, tend to have the architect will lead the entire team. As far as my experience is concerned, every project architect will take the lead of the project, because the architect has to travel throughout the project, whether in the design, whether in the planning stage, whether in the execution stage. So the architects plays the prime importance for any building execution and construction. Okay. And the important thing is, all the three, like the client, after the client, architect important, and further engineers are important. So this is the cycle which we need to follow. This cycle is very very important: client, architect, and the engineers. So this is the design and the build cycle, which I want to convey to all my architects present here. And this is my first portion of the presentation, which I want to highlight the importance of the architects and the importance of the engineers, and how much percentage problem my water sanitation gives. Okay. So having said this, having covered this part, let me move on to the real case study. Case study one. See, way back, actually, client called us, that is me, in the sense, they are facing a lot of problems at one apartment. There were 10 apartments in a city wherein the source is well water. 15 borewells are there. The process is from the borewell, it is going to the sump. From the sump, it is going to the overhead tank. From the overhead tank, distribution happens for various towers, but everything by gravity. Water is used for bathing and cooking. The complaint is, the complaint was, the main complaint, when when a tenant opening the tap, is they were getting black color water, foul smell. Since lot of childrens were there, childrens were there when they consume the water, when taking the bath also. At around 15 days to 1 month, they are all suffering from diarrhea, vomiting, stomach infection, so many things they were facing. And halabulla, something has happened, lot of disturbance happened there. Audience, what went wrong there? What would have happened there? Anyone can tell me what would have happened there? Just guess what would have happened. I think our own people also, our own audience, even Srivastava also can respond, Srivastava. Again, I'm repeating. From the tap, black color water was appearing, foul smell. Residents reported health issues like diarrhea, vomiting, stomach infection. When they called us, we went for audit. Almost 15 days we were going through the process. But that is
Maybe,
very, very simple. Yes, madam.
maybe
Yes,
it
madam.
got contaminated through
Water
some
line and drainage
externals.
line, water line and drainage line got mixed up.
Water line and drainage line got mixed up. This
Mixed
is
up.
one. Okay, mixed up is okay. How it would have, because see, Eddie Tower, it's a very great big consultant involved here, big architect involved here. How it could happen?
Backwater was not installed.
Sir, what is that, sir?
Backwater was not installed. Backflow walls.
Backflow walls.
Or cross connection of
Cross connection done.
the flushing line with domestic water line.
Okay, now let me put it like this. I'll just get into this actually. See, when we analyzed the thing, when we audited, see, the first point is there were 15 borewells coming to the sump. We want to analyze which borewell got contaminated. Immediately, the action taken was to test the complete borewells for physical characteristics, chemical characteristics, and biological characteristics. All the three. The result was showing all the borewells are fine, but 2 borewells showing bacteriological, that is the biological characteristics 2-3, particularly E. coli was present. That means the conclusion is it is contaminated. How it does the 2 borewells we identified. The 2 borewells identified, immediately we told them to stop. Plug it. And to our surprise, we want to understand how it is getting mixed. To our surprise, manual was present next to the borewell, and the manual, when we opened, it is not plastered. Totally, it is not plastered. All the sewage that is going to the STP, all the sewage water, it is going to the borewell. Here, the moment I say this, what could be how it could have been avoided? It could have been avoided. Normally, borewell should not be present next to the manhole or next to the septic tank. At least it should be 15 feet or minimum 20 feet away from the tank. This is the one of the things which I am showing. 2 borewells contaminated, which indicates sewage infiltration. Manholes internal and external not plastered. People may say, why manhole externally to be plastered? No, it has to be plastered. Where is the role of an architect comes here? It is very, very important. When an architect sit across the table, all my services engineers will be there. and he also ensured that these things should not happen. When from the coordination drawing, he should also, inform. He should also discuss with my plumbing public health engineer, boss, this is not the way. You should not keep the manual, because consent so many things may happen. Because see, for your information, when we call the quality department, they are showing complete signing of all the people that is being signed, the plaster, this, that, and all. So, audience, again, I'm insisting you, any manuals you are keeping next to the borewell, first of all, it should not be there. Number two, it should be airtight and watertight. That is very, very important. So, these two important takeaways to be taken care during the planning stage. And I'm sure that during planning stage, all these things can be taken out. Even suppose architect got missed out or engineers got missed out, this has to be noticed by the site during the construction project manager, and he should highlight it immediately, because these things we should not play with our tenants or other people. So this is the case number one. Now coming to this is what the manual, how it is all functional. You see the manual, how it is getting functional. And now to, so this is a very, very interesting. Again, I'm not quoting which hospital, which this one again, sir, to the audience. See, this is an hospital for 450 beds. The problem is leakage from the toilets. Client reported top management that it was a new hospital. How it can happen? How it can happen? They called me. We means myself went to the boardroom of my director of that particular hospital. The moment I stepped in, he used all types of words and told me to get out from that place. I understood the gravity of the problem. I understood the gravity, and immediately he told some other doctor, please accompany him and show him the place. He accompanied me, and I went to the place. Believe me, when they were showing the ICU, intensive care unit, wherein the patient was lying in the bed, and the above water leaking to the body, and that was the thing happened. To a surprise, it was sewage water. It was sewage water leaking. That means from the toilet above, these leakages happened. Just imagine my position, to that at that stage. Okay, so what went wrong here? Why it got leaked? Anyone can tell why it got leaked? 100% waterproofing. People were saying. My site manager was saying, 100%, sir, leak proof, sir. You see the paper, sir. What could have went wrong here? Waterproofing failure could have happened. Pipe joint leakage, trap leakage, drain pipe leakage, water entered the ICU's false ceiling. They may impact ICU bed shifted, ceiling dismantled, equipment relocated, rectification cost, 10-15 lakhs gone. These things are all happened end of the day. But what is the lesson here, sir? Anyone can tell what lesson here? What lesson? I think architect can come forward and tell me. What lesson here? At least one. Avoid placing toilets above ICU or OT. Avoid placing pantry above ICU or OT. Avoid janitor rooms. In short, water like wet, anything wet structure, don't keep above ICU. Irrespective, people may say 200% waterproof, this person, don't believe them. So please, these are my takeaways. Wet areas must be carefully zoned. ICE OT must be free from plumbing risk above. Early coordination with the plumbing consultants is critical. A small design decision can prevent major hospital failures. So this was the thing, so much I got it. I'm just little away from this topic. I purposely went into my management. I mean, in the sense, called all my planning team, and whatever I got, I have given to them. Okay, I have given to them. I have thrown everything to them that please, because it is not in one hospital. It was happened in 2-3 hospitals, and further, this learning improved our all my planning, design, architects, everybody worked during the period of that. So important takeaway is this. So heaven's sake, please follow this strictly, these golden rules, irrespective of the work what you are doing it. You see here, my planning has missed it. My planning means during the design stage, my project manager also missed it. The execution also, these people have whatever it is in the drawing, they were gone. Not even a single engineer pointed out that this is going to be a problem. Okay, so this is my second case for you. The third case, just see here. This is related to again the duct. I think Minesha was telling me this, and then putting it as a case study. This is a residential apartment, 16th floor. The problem came after 3 years, because during the design stage, when I was there, in fact, we were across the table when architects was present. Lot of ducts were there. We were telling them that, sir, we need access to go to the church. Suppose tomorrow any leakage is happening means we need to access 14th floor, 12th floor. We want access to go to the top. That's all, sir. Nothing else. They have not listened. At the end of the day, always they win. In the sense, some lot of people will realize, but some people will not realize, and no other go. We are only the contractor, and accordingly it has been done. Now, after 3 years, occupant, big people were staying there. Now they are reporting lot of leakage in the shaft. It is because, again, I'm telling you, the decision maker will tell, sir, this is a new building. At 10 years, life should be there minimum. Let us see after 10 years. Sir, no. After 6 months, something may happen. After 3 months, it will happen. After 1 year, it may happen. So we have to be prepared. Like our minister was pointing out, operation and maintenance are the key for any function, any good functioning of the building. So what went wrong here? Anyone can tell what went wrong? Just showing this. See, earlier I told you again this one. Similarly here also, just I want to point out here, there is a swimming pool. Swimming pool also once contaminated because there was a manhole going side of the building which was not again plastered. It was yet again plastered. I just thought I want to inform you here. Now, you just see this shaft. I think Minesha's slide was showing beautiful access and each floor to go inside the shaft or platform to attend. You just see here, you want to access this is not the platform. This is only your sunshade and your chacha. But it was happening leakage at the 14th floor. It was dripping, everywhere dripping. When we were telling you them access to be provided from bottom to the top, it was not provided. It was not provided. Now, after 3 years or after now, still it is leaking. And now permanent structure they are going to do from bottom to top to arrest this. Again, is going to spend money now. Again, it would have been done in the initial stage, So this is another failure of the design, in the sense from the operation and maintenance point of view. So a leak is suspected inside the vertical pumping duct, no access point for inspection and repair. What's the consequence? So wall had to be broken, damage to interior, high repair cost. Key lesson: plumbing, water and sanitation systems require inspection, maintenance and repair. Access panels in service ducts are essential. A small design decision during the planning prevents major maintenance problems. So this is the third one. Now coming to the four same residential building, see this is very 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 important from the trap point of view. From the trap point of view, that is a G+1 building. A local architect has been appointed, and it's a bungalow. Suddenly, is means smell from the leakage from the first floor toilet was happened. Two occupants fainted. It came in the newspaper also. Two occupants fainted inside the toilet. In the first floor toilet. First floor Indian water closet. Anyone can tell why these two occupants fainted inside the toilet?
Due to toxic gases getting released.
Absolutely fine. But why that gases is coming, madam, when we are all in the standard, we are all living in the standard world? How it can happen? And that to a bungalow.
Poor planning, surely.
No, no, not planning. I'll tell you. When during the design stage when you want to go for Indian water closet, sunken one, how much sunken we need to keep? I think Minesha was just telling. Earlier, those days, 450 mm required. At least now 300 mm required for Indian water closet, latest closet to be put. When you want to sink the 300 mm, our architect and structural engineer particularly not allowed the client, not allowed the one to do that, because it is located in a different place. But when you sink that, their architectural view is something getting affected, and because of that they are not done. Okay, but fine, they are not done. But and because of that, what happened? I was just saying that they have constructed the closet without the trap itself. Normally, Indian water closet will come with the P trap. I'll show some of the trap here. Importance of the trap. Before going to further, I want to inform my audience about the trap. I think this has been explained by our BOPK, Prasanna sir. But again, I'm repeating because this is very important to accommodate, so that our architect, planning engineer should understand what it is. This is a trap installed in each fixture to prevent gases from entering the house. The trap is always filled with water. The trap most commonly used with the plumbing fixture is the P trap. This gets in because of the shape. Traps are required because they prevent sewer gases from entering a building and causes serious illness or death from the entry. Okay. The term trap seal refers, this is the water seal being held in the bent portion. What is the trap? It will be defined in various traps actually. Nagani trap, in the balcony we have to keep it. P trap, S trap. So many traps are available. And particularly gully trap, and more importantly, one intercepting trap is there. What is the difference is, it all depends on the seal only, water seal. If it is 20 25 mm Nagani trap, 60 70 mm gully trap, and if it is 100 mm or 100 or 150 mm, it will be intercepting trap. Okay, coming back to the problem. I told you about the problem, no? Now coming back to the problem, you see here, this trap is being connected down, taken to the manhole, and the scenario is like that. It is taken directly connected to the manhole located outside the municipal, and from the municipal sewer it is going to the nearest STP maintained by the municipal this one. Past 10 to 15 days, that STP was not working, it seems. See how it has happened, how that fainting has happened. 15 days not worked. Because of the 15 days non-functional of STP, the gases, that collection sump filled with sewage, and the smell got getting into the backside. That is, reverse flow is happening. And when reverse flow happening, where and all trap provided into the house, that is not entering. Where it finds a weak point is this house. They are not provided any what do you call trap, no? That got entered, and get the grandma and her what do you call granddaughter both got fainted. Surprising. I mean, the main reason is they lost their lives also. I'm just giving it to, they lost their lives also. Just imagine, because of the gas, because oxygen is required when CO2, when H2S comes across, they're taking the advantage, and my oxygen level has come down, and because of that is happening. So therefore, architects, therefore engineers, very very important is when you connect to the municipal manhole, provide one manhole where intercepting trap is being positioned, so that your smell will get avoided. Well, this is after that incident, government has given a strict instruction that all the manholes getting connected to the municipal should have an intercepting chamber. So the problem came where? Because of my elevation, because of my feature, these things are required. Please, I'm even saying, please be generous, and but this is a collective decision. Again, there should not be blame game. See the fingers, all fingers pointing everywhere. I always tell all my engineers worked throughout, don't blame each other, come together, and then I'm sure that you all will lead a good design, and so that good effective project will come up. So the key lesson here is design issue sufficient sunken slab depth to be provided to accommodate P-traps in an Indian water closet, vent pipe to be provided with intercepting manhole where trap to be provided before connecting to the municipal. See, sanitary plumbing design is a critical life safety requirement, not just a construction detail. So this is what I conveyed. Again, I'm repeating here, before connecting the manual, provide an intercepting trap to connect it to the manual to avoid these things. Okay, so this is happening everywhere. I might just to see these case studies taken very carefully and giving it to you during our regular sessions. Lot of things are there from the design aspect. Also, we will able to communicate to you what things required, what not, the do's and don'ts. Everything we will able to address them. Okay. Now, last two case studies which I want to quickly tell you. Right. Coming back to the file. This is related to the STP. See, there is an again residential apartment wherein, okay, suddenly people sitting at the corner of that apartment were not able to sleep because of excessive noise, because of sewer order, because of disturbance, especially during night hours, faced serious discomfort and sleep disturbance. This is again residential tower, which is number of floors 20. What I have purposely not put what for it is cost. Anyone can tell what went wrong, why that particular row was not having the disturbance. Anybody can tell? I hope all are with me, right? Everybody is with me. I'm just it's very very important. Already my Minesa has given the clue here. I'm just giving you. This is related to STP. I'm putting it very clear. Related to STP.
Ventilation not planned properly.
Sir?
Ventilation not planned properly.
Exactly. No, I know, sir. I know you will tell all the answers. I'm very clear. Now you know very well. See what happened, I'll tell you. During the booking, during booking of flats, people will show people will come and book and go. To your bad luck, to the concerned person bad luck, the STP was located below that particular tower in the residential building. Because STP located below the tower, all my lines, see, when you are doing it anything in the basement, you have to mechanically do all kind of ventilation. For example, when you are keeping it outside, you need to have everything. Oxygen plays a major role. You need to have 12 to 13 air changes per hour. That is a component from the HVAC point of view. But when you are keeping the STP below the basement where no ventilation, you need to have 25. That is double the air changes per hour. Okay, that is all done. That is one part of it. The second part of it is, please listen. The ventilation, when they are taking, they have to take it at the top. All the vents they have provided, they are not insulated at all. You can just see here. all the ducts has been taken, not insulated. Is another this showing another. There is no sufficient height also here. People has to crawl, go and then maintain it. People has to crawl, go and then maintain my steep. How one person from this end to that end people can go? You just see, imagine here. This is what I am telling you. People looking into the architecture from the architecture outside. But when comes the inside, operation and maintenance, they are not. I am requesting you all, be generous in the sense, be very, very clear that we need to, have provision for the O&M, and particularly it showed affecting my the residents. What happened now when it is being taken? Lot of noises. They are not acoustically done. In fact, there should be a compressor with complete acoustic treatment. Then we suggested to go for acoustic treatment, all blah blah blah. But happened is happened. There is no other way. STP has to be there. The takeaway here is, as far as possible, STP don't locate below the basement. First of all, number two, if there is no space, provide the STP in the driveway, okay, or outside the external. That is what I want to convey to all of you here. The problem is improper location, insufficient ventilation, poor duct design, exhaust not extended to the terrace level. The key lesson, key takeaway on your next step of action is avoid locating STP below residential towers, prefer location under driveway, podium, or separate utility zone. A small planning mistake can lead to long-term noise and odor problem for residents. That's it. That's a message giving it to you. The last case study from the stormwater drainage point of view. Stormwater drainage point of view, wherein little design is here. Okay, the project is extension of existing airport. The problem is client reported major stormwater issue. At 1 o'clock, 1 a.m., he got a call from this one site that there is a serious issue in the the departure area. Rainwater overflowed into the passenger department zone, created operational chaos affecting passenger movement in the late night. What went wrong here? Anybody can tell me what? There is a building. We were doing the extension part of it. In the building, there are all the two sides, gutter is there. Sufficient size, everything is there. What went wrong here? Why it got overflowed? Normally in that particular state, rain may come anytime. So that's the thing. Actually, I think I'll show the figure also. This is the structure. This is the extension. At sudden moment, there is a gutter both sides. This gutter got overflowed, and the departure area is affected. And similarly, this has happened even in our Mumbai as well as in our Hyderabad also. Okay. Anybody can tell me what could have happened?
Maybe the slope calculation wasn't appropriately done.
Madam, I am not getting into the design aspect at all. That is another story which we can discuss later. But the point here is very, very important.
I think these.
You are right. One point I agree with you, but that is not the problem. Yes.
I think the sunken design of the roadway, I think there is the problem of.
Okay. Quickly, because I think timing I want to keep it up. So let me put it like this. See what happened now? I'll show here only. See, sudden rain came. Here, this membrane is happening. It was happening. What happened now? The membrane happening. All my vendors have kept their equipments, everything at the top. Everything at the top. During this heavy rain, everything came into the spot of the gutter and blocked my outlet. Blocked the outlet of this. Completely blocked. And because of that, it got overflowed. Here, what was the solution? See, the area is more than 1,000 square meter. In fact, during the design, we will able to tell you all these things for the architect. Normally, you would have seen our Sarath Rao sir given one overhead tank pipe sleeves and all. Normally, in a house, what are the things will be there? Inlet point will be there, outlet point will be there, your drain line will be there, anything else will be there. One important thing will be there. What is that? Overflow pipe will be there. Correct or wrong? correct? Overflow pipe will be there, right? Here, such a big area, we primary pipe is being given. We need to always keep a provision for the secondary pipe or emergency pipe 100 to 150 above. We need to keep it so that anything, anything get blocked, that water will overflow and that will be taken out. And that was missing here. Who was missed here? Designers. Design people have missed that. Design people have missed it, and it was not noticed by any of the lead. Because when I say any of the, it means it start from my architect, planning engineer, everybody, this is being missed. And that was the point there wherein that chaos have happened. And when we went there and see, when we went and saw what to do, we have to get sorry figure from the management, from their management, and immediately that redundancy has been taken care. So the problem here is temporary blockage during construction activity. Vendor material placed on the terrace, it blocked the roof drains. Rainwater accumulated rapidly on the terrace and eventually spilled into the areas. The solution for large roof areas, designers, architect must provide overflow or emergency secondary pipe located 100 to 150 above the main outlet level. The takeaway, always incorporate redundancy in roof drainage systems, especially in public buildings and large roof spans to prevent operational disruption and safety risk. Okay, and so almost taken 6 case studies for all of you to understand where what is required, what all the things to be taken care by architect, engineer with respect to water supply, sanitary, STP, and then stormwater one case. So many thousand cases are there, but just I thought I can brief you on all these things so that you are all well aware of the system. So, but in detail, we will cover it up in the as Minesh was saying, in the courses which is going to happen in April. So the any building, anybody wanted to see the beautiful it is, but at the same time, I want to everybody to tell architecture, this building is architecturally looking fine, services wise looking fine, structurally safe. All the 3 criteria to be maintained. This is what I want to convey, or I, on behalf of IPA, wanted to convey. A finished product should look like a finished product. This is what the message which I am just trying to convey to all of you. And before I end, I always end with the 2 important slides. Sanitation is more important than independence. Never stop fighting until you arrive at your destined place. That's unique. You have an aim in life, continuously acquire knowledge, work hard, and have perseverance to realize the great life. APJ Abdul Kalam, wishing all the participants best. And see, carry your own water, you will learn the value of every drop. Thank you very much, and thanks for the opportunity given by the CP. There are other there which I don't want to getting into all these things, and hope this is sufficient for my audience today. Thank you very much. Thanks, madam.
Thank you so much, sir. Thank you, sir, for the brilliant, comprehensive, inspiring close to our academic sessions. The case studies, the clarity, and the call to action are truly fitting culmination to this training program, sir. As we come towards the closing of today's program, I warmly invite our respected Registrar, Sri R.K. Oberoi, sir, to deliver the vote of thanks.
We can have a question hour session. Wait, Q&A session.
Yes,
we need to have Q&A session.
For Q&A session, my co-host Ayushi will start. Over to you,
Thank you
Ayushi.
so much. Am I audible? Am I clearly audible?
Yeah.
Yes, audible.
Thank you so much, sir, for this innovative and really brainstorming session. Um, the real life case studies gave us learnings that are truly valuable and made us realize how even smallest of the design decisions can impact human lives in huge ways. So there are a few questions from our participants. Beginning with the first one, what precautions and design considerations are needed so that if in any case toilets are required to be placed in areas where there are other major areas immediately below them, what precautions we should take?
No, the main precaution with respect to the residential building, if you ask me, for example, see, lot of case I'll tell you, kitchen will be there. What happen now when you have the kitchen, about toilet should not be there. Now these are small, small basic things and the rule to be followed. But at certain circumstances, it cannot be avoided. But what I am trying to tell you is please avoid, because see, we are all believing in somebody's work. It will not be 100% perfect. Waterproofing, people will say 10 years guarantee, 20 years guarantee, but I have seen no, no, no way. So please avoid all those things so that at least human life threat will not be there. This is what come this went.
Understood. So for the first case study, one participant asked, will deep borewell casing will prevent that to a certain extent?
No, no, no. Borewell casing and all will never, never prevent. See, borewell is a borewell, and manhole is some intrusion. If it happens, what will happen? See, that is what for him. Another answer I will tell you: swimming pool when you are constructing, retaining wall 100% perfect. People will to tell, like no water should go in, go out, right or wrong. But still, it was going inside. How? See, even we design anything, perfection of construction also should take place. But it was not so. Everywhere you yourself can see, even in any campus, problem will happen. What happens is better to we need to take the precautionary measure. We should not unnecessarily take risk. Don't take. Let us not take any risk in providing a manual, in providing this one nearest to that. That's what we are saying.
Mhm. Yes, sir. Some people have noticed that rats or some insect infestations happen through the shaft or drainage pipes. How can we resolve that?
No, no. For that, I think Prasanna sir is here. Actually, see, rat guards. A lot of guards are there, which we can install the guards so that it will be prevented.
Then again,
We,
SVN, can I add on this?
yeah, Minesh.
See, the water seal plays a very important role. When we talk of say 50 water seal for the traps, so again the gully, there are also the gully traps at the bottom of the range water stack, at the bottom of the stacks. Providing gullies with minimum 100 water seal is very important because this prevent the rats, worming and all coming up into the drainage system. If you remember the incident, a very bad incident will happen, the SARS incident in China. It was all because of the foul gases passing through the air and it mixed up with, and because of that the infection spread. So this water seals becomes a very important part when you talk about the drainage system.
I thank you all again for taking all these questions so patiently and answering elaborately. I pass it over to Shrutika ma'am now for further coordination.
So, as we come towards the closing of today's program, I warmly invite our respected Registrar, Sri R.K. Oberoi sir, to deliver the vote of thanks. So, over to you.
Before that, Madam Shrutika ma'am, just a small thing. Are we not showing the exact program of IAPL?
IAPL is there, no, madam?
Yes, it's there, sir. After the vote of thanks, it's
Okay.
there. Sir.
Okay.
Oh.
Thank you, Shrutika ji.
Thank you.
Namaskar, respected dignitaries, distinguished speakers, esteemed participants, ladies and gentlemen. As we come to the close of this enriching one-day National Capacity Building Program on integrated water and sanitation, the blueprint of sustainable architecture, it is my privilege on behalf of Council of Architecture to propose the vote of thanks. At the outset, I would like to express our sincere gratitude to the Indian Plumbing Association for partnering us in organizing this important program. Such collaborative initiatives play a vital role in strengthening professional knowledge and promoting sustainable and responsible practices in the built environment. We are deeply grateful to our distinguished speakers for sharing their valuable insight and expertise. I extend our heartfelt thanks to Dr. Abhay Purohitji, Honorable President, Council of Architecture, for his enlightening address and for highlighting the significance of integrated water and sanitation system in shaping sustainable architecture practices. Our sincere appreciation goes to Shri Gurmeet Singh Arora ji, National President IPA, for his inspiring presence and for sharing his rich experience and vision for advancing sustainable plumbing and water management practices. I would also like to express our sincere gratitude to our eminent speakers, Shri B.O. Prasanna Kumar ji, Shri Sharat Rao ji, Shri Vinesh Shah ji, and Dr. S. Veerappan ji for their highly informative technical sessions. Their presentations offered valuable practical insights into plumbing systems, water management, and the critical integration of these services within architectural design. My special thanks to all participants who joined this program from across the country. Your keen interest, active participation, and thoughtful engagement truly added value to the discussions and contributed to the success of this program. I would also like to acknowledge the dedicated efforts of the team COA-TRC Delhi, headed by Dr. Rashmi Tandon. I would also like to acknowledge the dedicated efforts of the team COA-TRC Delhi, headed by Dr. Rashmi Tandon, who worked tirelessly behind the scenes to ensure the smooth and successful conduct of this program. With these words, I once again extend my sincere thanks to our esteemed speakers, collaborators, and our participants for making this program meaningful and successful. Thank you so much. Jai Hind. Thank you so much.
I Thank you so much, sir. Um, okay. Now, we before closing today's session, we have an important announcement for the participants. Today, this program have been your introduction, your blueprint. For those who wish to go deeper to truly master integrated water and sanitation design in a hands-on program. For this, I would like to call our convener, Dr. RASHMI.B.TANDON ma'am, to introduce formally these sessions. Over to you, ma'am.
Thank you, Shrutika. So, as in the inaugural sessions, Gurmeet sir and Purohit sir had already mentioned about our collaborations, and the MOU between both the organizations were signed formally on 26 February. And it was decided that we will come up with some training programs for the architect professionals. And as a precursor to that 5 day, can you just mute yourself, Rohit ji? I think there is some background noise. Yeah, thank you. So it was decided that as a precursor to the 5 day offline program, which we are planning between 6th to 10th April, and it's going to be Indian Architectural Plumbing League. And those 5 days will have rigorous sessions on plumbing and its integration to architecture in more holistic manner. And a few of the speakers have been here to generally sensitize and orient everybody to know the importance of it and how sustainable blueprint is so very important for our better tomorrow. And as a part of 5 day program, it's going to be site visits also planned. We will share the detailed brochure and the poster for the registrations very soon. And I hope that the participants today have had an enriching day throughout. And on the registered email IDs, we had already shared our feedback form with everyone. And I'm now requesting my team to pin that feedback form on the YouTube live chat, which will be available for 15 minutes for you all to give your feedback. And the responses will be recorded on the timely basis. And we hope to have a continued collaborations with the industry partners. And I hope that today's session was a fruitful one and you all had large takeaways from today. Thank you so much everyone for joining. And now we are just spinning up the feedback and making it active. So it will be on till let's say 4:50. We will close it at 4:50. Is it okay?
Yes, ma'am.
Make it till 5, man. What is that?
So form is the participants can fill in their response to the feedback form, and my team can pin it up on the YouTube chat.
Sorry.
Okay.
Ayushi, is it pinned up on the chat?
Yes, ma'am. I have shared it on the live chat. Everyone can access it, access the feedback from there.
And also pin it up on the chat so that it's easy access. So this form will be active for next 20 minutes. And based on this record, we will share our certificates of participation for today's event.
And Rakhi ma'am, can I add on what you said on about the IAPL?
Yes, sure.
Yeah. So in IAPL today the sessions were just from the orientation sake of view, just giving a cursory on how the systems can be planned with respect to the capacity building, and a very generic one. But what we envisage is during the 4 training sessions of 4 hours each, starting 6, we'll be going into more details of each and every session. So for example, there will be a separate session on codes. There will be a separate session on water supply, drainage, indirect waste. I mean, plumbing will be divided, the entire plumbing system will be divided into 7 or 8 different topics, and there will be 8 different speakers taking the classes. And it will be more detailed and more interactive ones, wherein every architect or every participant can resolve their queries with us.
Yes, very true.
So now, can we leave or we need to stay here?
All of you can leave. Thank you so much for being here. But our YouTube stream